Hey, how's it going, everyone? In this video, I'm going to be walking you through everything that you need to know to get started with the Dart programming language. This is a course that a lot of people have been requesting over the last couple days, so I wanted to just make it really quick. Specifically, a lot of people have been asking to learn the Flutter framework. So the Flutter framework is a framework that was created by Google, and it's used to build mobile apps and also like websites. And in order to get into Flutter, you have to first know the Dart programming language because that's what it's all done in. So this video is mainly targeted at people who are new to computer programming or who are new to the Dart programming language, and you just want to learn all of the core concepts, with the idea being that you could go on and build stuff in Flutter or just continue building stuff in Dart. Now, Dart, believe it or not, is actually one of my favorite programming languages. I learned it a couple years ago, and I just think it's really, really fun to program in, mostly because it's a new language. So a lot of the programming languages that people use nowadays have been around since like the 90s. So they've been around for a long time, like, a couple decades. Dart is fairly new, and because of that, I think there's a lot of features and a lot of things about it that are really polished and that, sort of take lessons from these other programming languages and add them in. If you know JavaScript, Dart is very similar to JavaScript. There's a lot of similar syntax, a lot of similar ways of doing things, so you'll be able to pick this up real quick. But this tutorial is designed for people who have absolutely no experience to programming. So if you're coming in and you've never written a line of code in your life, this is the video for you. Or if you've done some programming and you just want to learn about Dart, this is also going to work as well. But I'm going to be stepping you through each and every core concept in computer programming. And eventually then you can go off and build some mobile apps or do something with Dart that, basically do whatever you want with it. So that's a little introduction about what we're doing today. Now let's take a look at our environment. Now in this video, I'm going to be actually coding the entire video in this REPL. So there's this site called REPL, and it allows you to write code in this very consistent environment. So all of this code is actually going to run on REPL's servers. So basically I can write code over here in my little text editor, and then I just click the run button and then it'll run. So you don't have to set anything up. You don't have to download anything. You just literally, I'll put the link in the description for where you need to start. You just click on that link and then you have the exact same environment that I do, and then you can follow along with me. The idea being that once you get comfortable programming in Dart, then you can go off and set up your environment and do all those things that you want to do. But this is just a nice environment for this video. Perfect. Okay, now with that said, let's go ahead and get into the tutorial. So once again, we are going to be starting from the absolute basics of computer programming. So I'm going to be walking you through all the core concepts, and we're going to start right now. So when you open up this REPL environment, or if you're doing this sort of in your own environment, you maybe already know how to set that up. When you open this up, you're going to see with Dart that there is this thing called main. And this is actually what we call the main function. And we're going to talk about what functions are. We're going to get into what all of this is. But what you need to know for now is that inside of these two open and closed curly brackets, this is where we're going to be writing like 90% of our code in this tutorial. Okay, so any code that you put inside of this main function is what's going to get executed by Dart. So when we write code, we're basically writing instructions for the computer to carry out. And it's the instructions that I'm going to be teaching you in this video. So I'm going to walk you through all the different types of instructions that you can give to the computer. And I'll even teach you how to build your own instructions using like smaller level instructions and things like that. So all you need to know for now as we start off is that you're going to want to write all of your code here inside of what we call the main function. So inside of these two open and closed curly brackets. And we can get more into like what this does later once we have some more context. But for now, just know that. So I'm going to be working in here. Now, whenever we write computer programs, like I said, we're giving the computer a list of instructions. And that's really what we do as computer programmers. We're basically writing out just really, really, really complex sets of instructions. And like I said, we can take a bunch of instructions and bundle them together and then send those off somewhere else. So we can take these instructions and write them and organize them in different ways. But at the end of the day, we're just writing instructions. Now, generally, when you start coding, the first instruction that you're going to give the computer is you're just going to tell the computer to say hello to the world. And this goes back to like some of the first programs that were written and they displayed out onto the screen, hello world. So that's where we're going to start. Now, there's a concept in Dart and in all of computer programming of printing. And this is basically having the computer give us information. So when I say that I want the computer to print something out, or I'm asking Dart to print something out, basically what I'm asking Dart to do is give me some information onto the screen. And this is the most basic way that the computer can give us information. If you learn like web development, the computer can generate all these like inputs and all these cool components and elements. But when we're working in Dart, we're just going to be printing things out onto the screen. So the first instruction that I'm going to teach you is the print instruction. So you're just going to type out print like that, and then you're going to make an open and closed parentheses. Now, this is a very, very common, I guess, like syntax in computer programming where we have this name here. In this case, it's print, and then we have an open and closed parentheses. So we do this a lot. And this is actually what's called calling a function. And we're going to talk more about functions later. But just know that this is a really common syntax that we're going to use. So I'm going to say print. I'm going to make an open and closed parentheses, and then an open and closed quotation mark. And then inside the quotation mark, I'm just going to write hello world exclamation point. So this is your first line of code that you're going to write. So we'll just write this out. And then the last thing we need to do is add a semicolon. So anytime that we write an instruction in the Dart programming language, we always want to end it off with one of these semicolons. And that's really important. Now, here's the thing. You're going to see me forgetting to add in these semicolons. You are going to forget to add in the semicolons. Semicolons are the bane of computer programmers' existence, but there is a good reason that they're in here. Just know that probably the most common mistake you're going to make, and like I said, you're going to see me make this mistake, is forgetting to add these in. So right here, we have our first line of code, and I'm going to click the run button up here, and you'll see that it's going to go off and it's going to run it. So this environment over here on the right is what we call the console. And this is basically the most primitive way that the computer can communicate to us. So like I said, the computer can like draw things on your screen. This whole website, this REPL website, is basically the computer like drawing things out onto your web browser. But the most basic way that we can get info back from the computer is over here on this console. And that's really all you need to know about this for now. But just know that this is the way that the computer is going to be communicating with us. And we'll also be able to like type things into here as well as we go on. Okay, so we have our first instruction here. And like I said, this is a really common instruction, always is going to end with a semicolon. But the thing about computer programming is not only do we want to give the computer one instruction, we want to give the computer many instructions. And really, as a computer programmer, all you're doing is just figuring out which instruction should I give the computer and what order should I put them in. And so that's the next concept that I want to talk to you guys about, which is writing multiple instructions and the execution flow of the computer. So what we're going to do is we're actually going to write a computer program that's going to draw out a little triangle onto the console over here. And I'm going to show you how to do that. So let's start with this first print statement. And in here, I'm going to start drawing like the beginnings of a triangle. So I'm going to draw the base of the triangle first. So we'll draw this guy right here. And then I'm going to put like three of these like underscore characters, and then I'm going to put one of these bar characters, okay? Now what I'm going to do is I'm going to copy this line of code. So I'm just selecting this, and then you can hit Command C if you're on a Mac, or Control C. You'll see me doing this a lot, copying the code. I'm going to paste this right above it, and then we're going to continue on with the little drawing. So you'll see here, now I'm continuing on like drawing this little pyramid, and my computer's adding in a period. So now we're going to take this next line, we're going to copy this, and we're going to paste it over here. And once again, we will do this. So you can see this little pyramid is kind of starting to come together. And this is going to be a really good way for me to explain how the computer is executing all of this. Okay, so we've drawn out this little triangle. And you'll see here that on each line of code, I have this text that's inside of these quotation marks. Now, this is what's called a string. So anytime that we have sort of plain text in our program, we call it a string. And that's generally going to be in between these open and closed quotation marks. And so what I'm doing here is I'm telling the computer on each one of these lines to print out a different part of this pyramid. So if we run this computer program now, you'll see that the computer actually prints all of this out. And this brings me to, I think, one of the most core concepts in computer programming, which is the execution flow of a program. So when your computer goes through and executes all of this code, right? This code's written in Dart. The computer can understand how to execute that. So when the computer goes and executes a Dart program, it starts here in this main function. And like I said, you don't need to worry too much about what a function is. This is essentially like a container that we can put different lines of code. So your computer is always going to start here in this main function. And then what it's going to do is it's going to go down and execute each line of code individually. So it's going to start with this line right here, and it's going to print this out. So it's going to print out all of this text. Now you can see that that's printed out over here onto the console. So not only this sort of / and the little bar character, but also all of this space there on the side. So whatever you tell the computer to print out, it's going to print out. So check this out. If I got rid of some of these spaces here, now our triangle is going to be all messed up because this is going to be over on the left. So when your computer goes through, it'll start with this first line of code. Once it's done executing that, then it's going to come down to this second line of code. And if we run this again, you'll see, so the computer starts up here and it executes this line. And then the next thing it does is it goes on to the next line and executes that. So your computer can only execute one instruction at a time, at least in the code that we're writing right now. Sometimes you can have it execute multiple things at once. But for right now, the computer can only execute one thing at a time. So the computer starts here, and then it goes down here, and then finally down to these last two. So the order that you put these instructions in, the order that you write your code in is very, very important. In fact, it's probably the most important thing when you're starting off with programming is making sure that things are in the right order. So for example, if I was to take this line of code and I was to put it up here, now you'll see that the program is all messed up, right? Because the instructions are in the wrong order. So the order of things, like I said, your first big lesson here is that the order is very important. Now, one thing that you'll notice here is how I'm formatting my code. And when we first start off coding, we're generally going to be writing programs that are really small. So the way that you format things isn't that important. But as you get better at programming and as you start writing more and more code, it's going to start to get really messy if you don't order things and if you don't use things like indents here. So generally, whenever we have a container like this main function where things are inside of these curly brackets, you always want to put a little indent. And that just indicates that these print statements are inside of this container. So you can use spaces or you can use tabs. It doesn't really matter. But that's another thing as well, is you're going to see me formatting my code as I go. It's something that you want to do as well. Okay, so we've talked about some of the basics, right? So now we know how to have the computer give us information, and we also talked about the execution flow of the program. So we execute one instruction at a time. Now, the next thing I want to show you is how we can start working with data. Whenever we write computer programs, we're always working with different pieces of data. So if you're building like a website, this could be like the users that are in your website. If you have like a finance app, maybe this is like different stock values or something, but there's always pieces of data that we're going to work with in our programs. And so what I'm going to do is I'm going to show you how to write a little program, and we'll look at how we can start managing the data that's in our code here. So what I'm going to do is I'm going to get rid of some of those print statements, and I'm actually going to write a program that prints out a little story. So the story is, there once was a man named, and why don't we call this man Stanley. So there once was a man named Stanley. Now what I'm going to do is I'm just going to copy this line of code. This is something that programmers do all the time. So if there's a line of code that looks like something that you need, you can just copy it and then paste it. So here I'm going to paste this story down. So the first line of our story is, there once was a man named Stanley, and then we're going to say he was 70 years old. So Stanley is 70 years old. And once again, I'm just going to copy this. And you can see sometimes when you paste things, like all the tabs get weird. And then down here, we're going to say he really liked the name Stanley. And then finally on the last line, we're going to say, and whoops. Okay, so sometimes REPL will do that because we're connected to the internet here, so it'll like mess up a little bit, but that's fine. So there once was a man named Stanley. He was 70. He really liked the name Stanley, but he didn't like being 70. Okay, so this is our little story. Obviously, like kind of a stupid story, but you can see here if we run it now, all of this code is run out. So this is, if you want to write a program that just prints out like a little poem or a story, this is exactly how you do it. But I want to use this as an example to talk to you about different data that's in our program. So if you look here at this program, there's actually two pieces of data that we are keeping track of. And maybe you can see what they are, but I'm going to walk you through exactly what they are. So you can see here that we have the name of the character in the story, which is Stanley, and then we also have how many years old he is. So these are two pieces of data that are really important to this story and that are repeated multiple times in the story. And generally, it's these pieces of data that we need to use in multiple parts of our program, which we're going to need to take extra care of keeping track of. So because the character's name is used multiple times and because it's so important to the story, and same with the age, these are two pieces of data that we want to, take extra precautions when we're working with them in our program. And the reason is because let's say that in this program, we wanted to change the character's name. So instead of the character being named Stanley, maybe I wanted the character to be named Oscar. So I want to change the character's name from Stanley to Oscar, but you'll notice that not only do I have to change it up here in this first line of code, I also have to change it down here in this other line of code. So there's two places here now where I have to change the character's name. Two places that I need to keep track of where the character is. Same thing for the age. So let's say that instead of 70, Oscar is actually like 35. So once again, I have to change it here and I have to change it down there. So there's two places now where I have to change the character's age. And whenever you're in a situation like this, when we're writing code, and this is a perfect example because we're repeating these values, whenever you're in a situation where these values are being used multiple times, this is a good place to use what's called a variable. And a variable is essentially a way that we can take the character's name and we can take the character's age and we can store them somewhere and then we can sort of reuse them throughout our program. Because the difficult part about this is that in this story, it's very short, right? It's 4 lines. So if I want to change the character's name, I only have to change it in 2 places. But let's say that the name Oscar or Stanley is in 1,000 places in our program across multiple files. This is something that's very common. So if this name, the character's name, is in multiple places, in order to change it, we would have to go to all of those places and change it individually. And this is not a good way to do things when we're talking about code. So let's take a look at what we can do with variables. Now, the first thing we want to do is store the character's name. And I'm going to show you just the syntax for doing this, and then we'll talk a little bit more about it. But I'm going to say string, and then I'm going to say name is equal to, and then I'm going to make an open and closed quotation mark, and then in here we're just going to put the name of the character Oscar. Now make sure that you end this off with a semicolon as well. Once again, you're going to forget the semicolons, everyone does. It's just a part of learning how to code. So we're saying string name is equal to Oscar, and what this means is that this string of text, like I said, anytime we have quotation marks and there's text inside of it, we call it a string. It's like a string of characters. That's kind of where that name comes from. So I'm saying that I want to store a string, this string Oscar, in a variable which is called name. And what's cool about this, when we create this variable, now if I want to refer to the character's name, I no longer have to say Oscar down here. Instead, I can use this special syntax. So I can put a $sign and then an open and closed curly bracket. And then in here, I can put the name of this variable. So this variable has a name of name, and obviously maybe this is getting confusing because I called it name. We could call this character name. So the name of the variable is character name, and what I can do is I can do what's called interpolation. So instead of having to write out like the text Oscar, I can just use this syntax, and the program is automatically going to insert whatever value is stored inside of the character name variable here into this story. So we can do the same thing. I'm going to copy this, and down here we have Oscar as well, and I'm going to paste that. So now instead of typing out Oscar, we're just doing what's called interpolating the character's name. So what I'm going to do now is I'm just going to hit run and take a look at this. So you'll see here that the story still has the name Oscar in both of these places. So when the computer goes and executes this code, let's say it comes down here to this print statement, and when it sees character name right here, it grabs the value that's stored inside of the character name variable and just puts it in there. So check this out. If I wanted to change the character's name, maybe, well, it shouldn't be Angela because it's a guy. So maybe we can change it to Michael. And now I'm going to hit run. And you'll see here that now the character's name, Michael, is updated in both of these places, and I only had to change it in one place. So unlike before when we wanted to change the name and I had to go through and like manually change it to Oscar, right, in both of these places, and I can't type this, right? Instead of me having to go do that and then me messing it up, because if it's in like 1,000 places, I'm definitely gonna mess it up. Instead, I can store it in this variable and then the program will just take care of it. So then when we wanna update it, right, if we change it to Jim, now you can see that it updates in both of those places. So we can store the character name in here. And like I said, whenever you wanna insert like the value of a variable inside of a string, you can use this $ and then open and closed curly bracket notation. We call that string interpolation because we're interpolating a variable's value into the string. That's kind of like the technical definition. So we can do that with our string. We can also do that with our age. Now in this case, the age 35 can also be a string, right? Because it's just kind of stored in here. And we're going to call this character age. And I'm just going to make this 35. So we'll replace all the instances of 35 in here with the character age. So 35 there, and then 35 there. So if I run the program, you'll see that nothing has changed. And here we go. First time I'm forgetting one of these semicolons. I'm definitely going to keep doing this throughout the video. The thing with semicolons is that there's some programming languages where you don't need them, and those are mostly the programming languages that I'm working in, so I'm not like in the habit of doing it. But hopefully I'm pretty good with that throughout the video. So in this case, you can see that nothing about it changed. It's still 35, but if I wanted to change it to, 64, I just change it in one place, and then it gets updated throughout the entire program. So these are really what variables are, okay? These are little containers where we can store values, and then whenever we want to refer to those values, instead of referring to the value itself, like Jim, we just refer to the variable name, and then the computer will sort of like put that value in there. And really the main reason that we do this is so that when we want to change the variable, we only have to change it in one place instead of having to change it in multiple places down there. Cool. Now, another thing that we can do with variables is we can reassign them. So there's really two ways that we can work with variables. We can initialize the variables and create them, and that's what we're doing up here. So when we initialize a variable, when we declare a variable, we're basically saying, okay, this is going to store a string. It's going to be called character name, and the initial value is going to be Jim. What I could do though is in another place in my program, I could modify that value. So let's say that down here in between the first part of the story and the second part of the story, I wanted to change the character's name. I could do that by just updating the variable's value. So now I can refer to the variable's name, character name, and then I can set it equal to something else. So now we, instead of this being equal to Jim, we could set this equal to Dwight or something like that. And once again, we are going to remember to put that semicolon there so we don't get yelled at by the compiler. So let's hit the run button now. And you'll see that because I modified the character's name, now when we start the story, the character's name is Jim, and then when we're finishing the story, the character's name is Dwight. So whenever we modify the variable, any code that occurs after that is going to use the updated value. And this brings us back to that first lesson that we learned, which is the order of execution, right? It's very important that we put this code in the right order. If I was to put this character name reassignment down here below the story, now the character's name doesn't change to Dwight. It's only when I put it up here before I do this print statement that it changes. So these are really like a couple core lessons, right? We need to make sure that the order of the program is sound, and then we also want to use these variables to store those pieces of data. Now, most of the time, if you have a piece of data in your code that you want to work with or that you're interested in working with, it's a good idea to store it inside of one of those variables. Now, So far, we've just been working with one type of data, which is this text. And text is kind of the most basic and I guess flexible type of data because you can just put anything in it. So again, we call these strings and they're just in between these open and closed quotation marks, and you can put any characters that you want in here. It doesn't really matter. But there are other types of data that we can work with as well. So I'm actually going to delete this little story here, and we're going to talk about the different data types that we have in Dart and really just in programming in general. So there's three main data types in all programming languages that we can work with. Okay, there's strings, which is plain text. So an example of a string, we kind of just saw a couple, but a string could be like, first name, right? And I could set this equal to Mike. So this is like a string of plain text. We're going to put the semicolon in there, and anything can go in here. So you could put like characters, you could put numbers, whatever you want to put in there. You could put emojis if the language supports it. I think Dart probably does. So you can just put any sort of plain text in there, and that's a string. It's the most versatile, it's the most flexible data type that we have, and probably one of the most common that you're going to be using. There's also two other data types though. There's number data types, and then there's what's called Boolean or true-false data types. So strings, plain text, numbers, and then true-false information, which we're going to talk about the true-false stuff because that's a lot of times confusing. So when we're talking about numbers in computer programming, there's two types of numbers. Okay, we have what are called integer numbers, which are whole numbers. So the counting numbers, things like 1, 2, 3, 4, 5, -1, -10, whatever. These are numbers that don't have decimal places. We also have floating point or double numbers, and these are numbers that have decimal places after them. Okay, so there's these two types of numbers generally that we're going to be working with, and this is for basically all programming languages. So an example of an integer, and you'll see here I'm going to create an integer variable. So I'm going to tell Dart what type of data I want to store in this variable. So up here we said string, first name is equal to Mike. Down here I'm going to say int, and a good example of like an integer would just be age. So like in my case, I'm 26. And this is a good example of an integer because I would always represent my age as the whole number. I would never say like, oh, I'm 26.4567, years old or something like that. I would just say that I'm plain old 26. It's like a counting number. These could also be negative if you wanted them to be negative, that's fine. And then we also have what are called doubles. So I could create a double variable, and a good example of a double would be like if you have a GPA, like a grade point average or something like that. So maybe your grade point average is like 3.5. So this has this decimal place after it. And the reason that we have to distinguish between an integer and a double, and I guess I don't know exactly why we do this in Dart, but generally it's because they're stored differently in the memory of our computer. So a string is stored different than an int, which is stored different than a double. And so when we tell Dart exactly what type of data that we're using, Dart will go ahead and be able to store that correctly and use it. So that's generally why we would do this. Okay, so strings, integers, doubles. And doubles can also be negative. Doubles could also be like 0.0, but it couldn't be like this. So you always need to have the decimal place after it. And then the final data type that we're going to be working with in computer programming is probably the least intuitive to a beginner, which is called a Boolean. So if we wanted to create a Boolean, we could just say bool. And Booleans are true or false values. So these can only have two possible values. Strings can have basically an infinite number of values, right? An infinite number of combinations of characters, whatever. Numbers also pretty much could have an infinite number of values, right? Booleans, though, can only have two values, true or false. And this Boolean data type is like the most important data type in all of computer programming. It's actually what all computing logic is based on. If you get to like like we're talking about like different logic gates and stuff in the processor of a computer, but a Boolean is true or false. So a good example of a Boolean piece of data would be like is registered voter. So maybe we're writing a program that keeps track of like who's a registered voter in your country. And so this could either be true, right? They're a registered voter, or they're false. So there's no situation where they're like neither of those things. Like they either are registered to vote or they're not. There's no middle ground where they're like kind of registered or whatever. This is a Boolean, a Boolean value, right? Another thing you could also say like is above 18 or something like that, right? Maybe this is for like drinking in your country, whatever. So is registered voter, that's fine. And a lot of times when we name these variables, you'll start with like is or something like that, just as kind of a convention. So these are like I said, the three main types of data. We have strings, we have numbers, and there's two different types of numbers, and then Booleans as well. Now, all of these values can be printed out over here. So if I wanted to, I could print, and you remember when we printed before, we just printed like some text that was inside of here. But anytime that you have a variable, and you can see here, already forgot the semicolon, but anytime that you have a variable, you can also print that out as well. So I could print out like first name. We could do that over here. You'll see that that prints out. I could print out, GPA, whatever. And then we could also print out is registered voter. Cool. So we're storing data inside of these variables, and it's so that we can reuse it throughout our programs. And when we want to change it, we only have to change it in one spot. So this is really like the core basics of computer programming, right? We talked about the order of execution, how we execute this line before we execute this line, before we execute that line. We're storing data, and then we're using it throughout our programs. So these are all like some really important concepts. Now, the next thing that I want to do is I want to dive a little bit deeper into some of these different data types. So we're going to dive a little bit deeper into strings, numbers, and then also Booleans, and we're going to look at how we can use them in different ways. Now, keep in mind that when we're writing computer programs, there's a lot of things that you have to learn before you can start writing some actual cool and like interesting programs. We're actually going to write some cool stuff as we go, but just know that as we're introducing these concepts, like there's just some prerequisite knowledge that we need to get out before we can start like really building some cool stuff. Okay, so with that said, I want to start talking about strings. So let's just go ahead and delete all of this stuff, and let's create a string, which is a variable. So I'm going to call this greeting, and I'm going to set it equal to hello. So this is a pretty common greeting. Now, the first concept that I want to introduce to you with strings, and actually we're going to print this out too, and I'm not going to forget the semicolon. The first concept that I want to introduce to you is this concept of an index. So whenever we're talking about strings, each character in a string has what's called an index, and a string itself has what's called a length. Now, let me show you this really quick. So I'm gonna put what's called a comment here. So if you put 2 forward slashes in your code, this is actually a comment. So anything that you type in here, you can see it's kind of greened out. The computer is just gonna straight up ignore this. So anytime the computer sees a comment, it just ignores it. And I just wanna use this to kind of notate. So when we have a string, each character in this string is going to have a particular index, and those indexes are going to start at 0. Now, this is a little weird, and if you've never coded before, this is something that's going to be kind of foreign to you. But whenever we are writing computer programs, whenever we're counting things, we always start from 0. It's just kind of something that we do. So the first character, this H, is going to have an index position of 0. So we would say that the 0th character in the greeting string is this H. The next one's going to have a 1, 2, 3, and 4. So this first L is at index position 2 in the string. This O is at index position 4 in the string. It's just something that you kind of need to get used to thinking about. So whenever we talk about like the first character, we're talking about index position 0. And this is the source of like just so much confusion and so many like bugs in beginners who are writing code like this. But just you need to keep this in mind that if I say like, oh, the character at index position 1, I'm actually referring to the E, not this H. The H is at index position 0. So just something to keep in mind, something to wrap your head around as we go forward here. So each character has an index position, but the entire string itself also has a length. Now, here's another thing that's just gonna throw you off a little bit. So the length of the string is actually one more than the last index position. So check this out. I have this greeting string, and I'm actually just going to put this on 2 lines here, but I'm going to print this out. Now I could say greeting.length just like that. And if I do this, check this out. I'm going to run the program, and you'll see here, and actually, sorry, we need to remove these open and closed parentheses. So I'm going to run this, and you'll see here that we print out a 5. So I say greeting.length, and it prints out a 5. So one of the things that we're interested in a lot of the times with these strings is how many characters they have. Now you'll notice that the length of the string is different from these index positions. So the string technically has 5 characters, right? 1, 2, 3, 4, 5. It's just that the last character is at index position 4. Again, this is just one of those things that you kind of just need to get used to. As a new programmer, you just kind of need to wrap your head around it. But we have these index positions, and then we have the length, and the length is always one more than the last index position. So when we're counting the length, we start at 1, 2, 3, 4, 5. So that's where we get 5 over here. But when we're talking about the index positions, we start at 0. So we say 0, 1, 2, 3, 4. Okay. Once again, you'll get more comfortable with this as you learn more about coding and as you write more code, but that's kind of like the first big lesson that we need to learn. So this length is what we call a property of the string. So this length tells us information about the string. And a lot of times when we're writing code, we're going to want to be able to get information about the different strings that we have, especially if we don't necessarily know, especially if we're not writing them out just like this. Maybe they're coming from a user or something. Now, if you want to refer to a particular character in the string, you can do that using this open and closed square bracket syntax. So you can say greeting and then an open and closed square bracket, and then inside of here, we're going to put an index position. So if I put a 0 in here, check this out, it's going to print out the character at index position 0. So we'll run this, and you see that it prints out the H right there. I could also say print out the character index position 3. So that's going to be this second L over here. Or we could say 4, and that's going to end up being the O. So once again, when we want to refer to one of these individual characters, we refer to it using its index. If I was to put a 5 here and I ran this code, you'll see that we get this exception, and that basically means that, hey, we can't print out the 5th character because the last index position is 4. So the computer doesn't know where to look for that. Okay, so that's a little bit about accessing a specific character. Sometimes we're going to want to do that. It's just a good idea to be able to grab one of those. Now, in addition to being able to get the length and being able to get individual characters, we can also use what are called string functions. We're going to talk a lot more about functions in this video, so don't worry too much if you don't understand what that means. But a function is essentially like something that the string is able to do. So what I could do is I could say greeting, and then I can say dot. And here I'm going to type in the name of a function that we can use with this string. And one of the most common is to uppercase. So you're going to type out greeting dot to uppercase and then an open and closed parentheses. Anytime you see this open and closed parentheses, it means that we're like calling a function basically. So I'm going to click run here, and you'll see what happens is this hello string down here is converted to be all uppercase. So we've taken all of these characters and we've converted them entirely to uppercase. You could also do to lowercase. That'll make them all lowercase. So these are ways that we can take this string and we can sort of modify it, right? So we can change it up. And so now this is completely lowercase. And there's a couple other of these. You can actually just Google like Dart string functions, and a bunch of these things should pop up. These two are really common. And also I just wanted to show you like just how that works. But there's some other ones as well that are pretty useful, and I just want to introduce these. So another thing that we can do is we can figure out if a character is inside of this string and at what index position it is. So I could say greeting dot index of open and closed parentheses, and then in here I'm just going to put a particular character. So if I put an E in here, check this out. When I run the code, it's going to say 1. Now what this means is that when I run greeting.index of, it's telling me, okay, the E is at index position 1. And so now I know where the E is in the string, so I can do different things with that. And this comes in handy a little bit, but this is just like a really common thing that you'll see developers doing, which is trying to figure out like at what index position a particular character is. So I could also put like an L in here, and you'll notice that there's 2 L's in hello. So if I put an L in here, it'll just return the position of the first L, which is that 2 right there. So it'll always return the position of like the first. So that's a little bit about index of. That one's really useful. There's also another one which is called contains. And contains is going to allow us to check to see whether an actual character or a string of characters exists inside of here. So I could say contains, and in here we're going to say contains, and I could put, for example, an E here. Now this is different from index of, because instead of telling us the index position of the E, it's actually going to give us a Boolean value back. And this isn't like one place now where you're seeing where these Booleans are coming into play. So I'm asking, does the greeting contain the letter E? And in this case, we get a true back. But for example, if I put like a 7 here, now you'll see that the greeting doesn't contain a 7, so then we get false. So those are just like some different ways that you can do that. And we might look at some other ways of using contains later in the future. In fact, I think we definitely will. Cool. So that's just some basics about strings. There's a lot more things that we can do with this. There's a lot more that we could talk about with strings, but it's kind of the main basics. And really what you want to do is just kind of start playing around with some of these different things. So the last thing I want to talk about with strings is something called concatenation, and then also something called interpolation, which we've already looked at a little bit. So strings are very unique because we can actually add them together. And this process of taking one string and adding it to another string is called concatenation. So check this out. I could create another string variable over here called greeting2, and I'm going to set this equal to world, and I'm going to put my semicolon there. I could do this. I could say greeting plus greeting2, and I'm actually going to put a space here. And if I run this code, you'll see that now we're printing out hello world, just like that. So we have this first string hello, which is getting printed out there, and then we have the second one that has the space and then world that's getting printed out after. So we're able to like add those two together. We call that concatenation. Okay, another thing that we can do, and we already saw this, is called interpolation. And interpolation is where we sort of insert a variable's value into an existing string. So here I could say the greeting is, and then I'm going to make this $sign and an open and close curly bracket. Now this is all taking place inside of these quotation marks. I can put the name of the variable, right? So I could even say like the greeting is, and then we could do like concatenation here. So greeting2. And so now the greeting is hello world. This is actually interpolated into here. And we could get rid of greeting2 if we wanted to. That doesn't really matter. But you get the point. So there's different ways that we can add strings together. We can concatenate them. This is really, 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 really useful for when we want to like format out a line of text or something like that with variables in it. But really, I think those are the main kind of core concepts of working with strings. So probably the most common data type that we're going to be using, any sort of plain text, usernames, whatever, it's all stored using strings. So these things are really good. Cool. So I think that just about wraps up what I wanted to talk about with strings. And so now let's go on to our next data type, which is numbers. So like I said, we have two different types of numbers. We have doubles, also sometimes called floats, and then we also have integers called ints. So these two numbers, you can work with them almost exactly the same way. It's just that one of them has a decimal point and the other one doesn't. So let's go ahead and create a couple of different numbers here. So I'm going to create an integer. Why don't we call this quantity, and I'm going to set it equal to 300. And then I'm also going to create a double. So this is a number with a decimal point. And why don't we call this price? And the price will be like $5.99. So maybe we're writing a little app for an e-commerce site, and we're storing the quantity of items that we have inside of an integer, and then we're storing the price of each one of those items inside of a double. Pretty common use case, right? Quantity is an integer because we're not going to have like half of something available. We're just going to have it in full increments. Now, when we're working with numbers, and first of all, I can actually just show you this without these variables. When we're working with numbers, we can do all the main things that you would expect to do with numbers. So we'll leave these variables alone for a second, and I'm just going to show you, you could do any type of math. So here I'm just printing this out just so we can see the result, but I could do any sort of arithmetic that I want. So I could do like 5 plus 3, we get 8. You could do subtraction. We could also do multiplication, and that's going to be using this star character. and then we could do division, which is going to be a // So all the 4 main math operations are in there. You can also do things like order of operations. So once again, I'm just going to put this on kind of its own line. So you could say like 5 plus 3 times, I don't know, 2 divided by 7 or something like that. And the program will automatically do like the order of operations that you would expect. So it would do like anything that's in the parentheses, then it would do the multiplication, and then finally the addition. So like whatever numbers that we're using in here, the Dart will be able to handle that. Like it can do all the main stuff that you would expect. Another thing that we can do is something called the modulo operator. So there's this operator in programming, we call it the modulo operator, also commonly referred to as like the remainder operator. And there's some cases where you'll see people using this. So you could say, so for example, if we said 10 divided by 3, right? 10 divided by 3, this is going to be 3.333 repeating, etc. Now, one thing you'll notice is that when we have 2 integers and then we divide them, we actually get a double back, just something to notice. But the modulo operator is basically like the opposite of, well, it's not the opposite of division, but it's like a complement to division. So the modulo operator is going to tell us what the remainder of something is. So I could say 10, and then I'm going to put this %. So we would say this is 10 mod 3. And you'll see here that we just get a 1 back. So 10 mod 3 is going to tell us what the remainder is. So 3 goes into 10 3 times, right? 3, 6, 9 with a remainder of 1. And that's what we're getting back here, which is that remainder. So modulo operator is something to play around with. It's not super intuitive when you first see it, but it's used in programming in, I would say, like some cases. So it's definitely worth being exposed to. Okay, so we have our integer and we have our double, and these are both stored in variables. And I'll show you some other ways that we can work with these as well. So you could do math just on these values. So you could say, quantity divided by 2 or something, we should get like 150 back, right? So we can do all the same math stuff with these variables, but specifically with variables is we can like increment them or change their value. So let's say that instead of making this 300, let's say that for our e-commerce store, we just got like 50 new items in. So we want to increase the quantity by 50. One way I could do that, and I'm just going to print the quantity down here. One way we could do that is we could say quantity is equal to quantity plus 50. And this is pretty common. So we saw before with the story how we can change the value of a variable. So we call this reassignment, right? So I can say the value of quantity is now equal to the current value of quantity plus 50. And this will should give us 350. You can see that over here. But there's an easier way that we can do this, and it's another syntax that you'll see people using. So if you're doing this thing where you want to add 50 onto like the existing value, you could just say quantity plus equals 50, and then it'll do the same thing. So this is like just kind of a shorthand that you'll see people use. And you could do subtraction there too. And I'm pretty sure you can do multiplication as well. So this would give us, like 1500. And then you could do division too. So those are different ways that we could just go about like, adding a value to the existing value. You'll see people do this a lot. Another thing that we can do is you can add 1 to these. And so if we wanted to add 1, we could say plus equals 1, right? So now the quantity is going to be 300. But there's a shortcut for this as well. This is really common in programming. So you could just say plus plus. So quantity plus plus. What this is going to do is it's essentially doing the same thing as quantity is equal to quantity plus 1, or quantity plus equals 1. Same exact thing. So we just say plus plus, and we run this, and boom, we get 301. So once again, we're not really writing any like interesting code here. All I'm trying to do is just kind of expose you to some of this like syntax that you're going to see. And the syntax is just like the way that these instructions are written. So these are all different instructions that Dart understands. I want to expose them to you a little bit so that as we go throughout the video and we start doing more advanced stuff, then you at least have some reference point. Okay. Now, in addition to being able to do all of that stuff, and you can do all of these with doubles too, it's the same thing. There are some more like I guess, advanced math things that we can do with Dart as well, but they're actually not going to be in here by default. So Dart has something called a math library. You're going to hear this term a lot in computer programming, a library. It's essentially just a collection of code. Just like a library is a collection of books, or normal library, a coding library is a collection of code or a collection of little like functions, basically just a collection of code that lets you do things that you normally wouldn't be able to do. So we're going to actually have to import this. Now this is going to be some kind of funky syntax here, but you're going to say import, and you'll notice that this is outside of our main function. So this is actually going to be up at the top of the document. You want this to be the first thing that you put up here. So you're going to say import, and then inside of quotation marks, we're going to say Dart:\math. And what we're doing here, make sure you put your semicolon. What we're doing here is we're saying, okay, I want to import all of Dart's math functionality into my code. And when we put this line up here, now we're going to basically have access to a bunch of different like mathematical functions that we can use. And I'll show you some of those. So we can do this down here in this print statement, just so I can print this out. But now I could say, for example, one of the things that we're able to do now is we can use the min function. So min right here, you can just type out the name min and then an open and closed parentheses. And actually, so maybe some people are confused by this, why I'm not putting a semicolon here. This is actually going inside of this little print statement. You can see this is inside of these parentheses, so we don't need a semicolon. I don't know if that's confusing anyone. And you'll get more comfortable with this syntax as we go. But the min function is going to take two values basically. So we're going to put two numbers in here. I could put like a 1 and then I could put a 9, and you'll see that I'm separating these with a comma. And if I hit run, this is going to tell me which one of these is smaller. So you can see here 1 is smaller. Like if I change this to 100, now it's going to give me 9 back. So sometimes this is useful. You'll see people using the min function. There's a couple other ones too. There's like the max function. This does the opposite. So it'll tell you which one's the maximum. There's another one which is called square root, SQRT. And in here you could put a number like 144. It'll give you the square root. So we're going to get 12 back, etc. So that kind of works. Now, once again, we need to have this line of code up here in order for this to work. So I'm going to delete that. If we hit run, now we should get an error. It says method not found. Method's another word for function. So we're going to put that back. Now I'm going to put this back. If you want to undo some code that you wrote, you can use Command Z if you're on a Mac or Control Z if you're on a Windows. And that's kind of a useful thing. Like a lot of times, you'll delete code by accident. You want to get it back, just Command Z, Control Z. Okay, so I think that's everything that I wanted to talk about with numbers. Now, I want to spend just a little bit of time talking about Booleans before we move on. We're going to talk more about Booleans later when we get into conditionals, these things called if statements. But I just want to show you really quick just a couple of things about Boolean. So remember, a Boolean is like a true or false value. So it's either true or it's false. And sometimes you're going to want to use these explicit values. You're going to want to type out false, or you're going to want to type out true. But there's actually some other ways that we can get get Booleans, which are called Boolean expressions. So once again, I'm just going to make a new line here so we can see this easier. So you could put true in here, and you can see that true pops out over here. But you could also put like a comparison. So you could say, for example, 5 greater than 3. Now in this case, 5 is greater than 3, so you'll see here that we also return true. You could say, if we said 5 is less than 3, now this is going to return false because this is false. So we would refer to this as a conditional this would be a comparison or a Boolean expression. That's another way that we could call it. But I just want to show you that. So there's, you could type out true, but true is equivalent to something like 5 greater than 3 or anything like that. So you can do like greater than, you could do greater than equal to, you could do equal to, which is like these double equal sign, etc. So we'll get a little bit more into these later, but I just wanted to point that out really quick. Okay, so the next thing we're going to do is we're actually going to start writing some programs that are a little bit interactive. Like so far, we've just kind of been talking about the different data types, different ways we can work with these, just to familiarize you with some of this syntax, get you comfortable writing code. Now I want to show you how we can write programs that are taking input from us as the user and then like giving us output. So this is when our programs are really going to start to come together and you can start like building some pretty cool stuff, which we're going to do. So I'm actually going to leave this line of code up here. We can just leave that there. It's not really bothering anyone. But I want to show you how we can get input from the user. So far, all we've been doing is having the computer tell us things, right? We're having the computer tell us a string or tell us some, equation or whatever. Like the computer's printing things out at us. Now I want to show you how we can give the computer information so that the computer has like different data that it can use. And the first thing that we're going to do is we're going to import something called Dart::io. And you'll see this a lot in computer programming. IO stands for input output. So this is the way that we interact with the computer, right? I give the computer input, whether it's through like clicking a mouse, typing text in, whatever, clicking a button, and then the computer gives me output in the form of like text like this or something else. So this is like low-level input output that we can do in the Dart programming language. Now, we're going to write a little program that just says hi to the user. So this is like the most basic sort of getting user input program that you can write. So I'm going to make a print statement here, and this is going to be a little prompt. So I'm going to say, what is your name? And really what I'm doing here is I'm sort of prompting the user to enter in their name. So if we run this code, and you'll see here it just says like, what is your name? But now what I want to do is I want to be able to have the user type in their name and then be able to say hello to whatever their name is. This is like, kind of the most basic thing that we can do. And the way that we can get user input is by using something called the standard input read line sync. And you're going to see how this works in a second. But anytime that we're trying to get input from a user, we always want to store it in a variable. Generally, we always want to store it in a variable. We talked about how variables are like a great way for us to organize our data and for us to store values. And so when we get a piece of information from the user, we want to store that. So I'm actually going to create a string. Now, any information that we get from the user from this little console over here is going to be in the form of a string. So it's always going to be stored in a string like this. So I'm going to call this string and we'll call this username. And I'm going to set this equal to, and now there's going to be a little bit of funky syntax here. So I'm going to set this equal to stdin. So that stands for standard input dot read line sync, just like that. Now this code, obviously, what's going on here? This is a little bit confusing. This is essentially the line of code that we need to write so that Dart is able to like get information from the user. So when we put this instruction here, we're telling Dart that we want the user to be able to type something in. And what's going to happen is the user is going to type something in, and then we're going to store whatever they typed in inside of this username variable. So let's go ahead and run this code and just see what happens. So you can see it says, what is your name? But you'll see that the program kind of stopped executing here, right? We didn't get any indication that the program was done running. The program is almost like halted. Now, if you come over here on the console, you'll see that you can actually start typing in here. So if I, for example, type out my name, Mike, like that, I can hit the enter key, and you'll see here that the code actually finished running. So whenever we do this standard input read line sync, this essentially pauses the execution of the program, allows the user to enter something, and then when the user hits the enter key or the return key, then the computer continues on executing. So what we could do now is if I was to print out, and we can use string interpolation here, we could say hello, and then in here we could say username. So I'm just printing out the, hello to whatever is stored inside of this variable. Now if I do this, it says, what's your name? I type in Mike, and now it says, hello, Mike. So we get this input from the user. Remember, the program's execution stops at this point and waits for us to type something in and hit enter. And then it stores that value as a string. Now it always stores it as a string inside of this variable called username, and then we can print that out and use that. Okay, so this is the basic flow of how we can go about getting input from a user. We're always going to do it just like that. Now, in this case, we're getting input from this console over here, you might be thinking like, oh, that's kind of lame. Like I want to be able to type into like a search bar and stuff like that. There's other ways that we have to go about getting user input with like search bars and graphical user interface elements. But in this case, we're just working here on the console. Cool. So now that we have a basic understanding of standard input and how we can get values from the user, I want to show you guys how we can build a basic calculator. This is a really, really good first program, and this will be kind of our first like real kind of program that we're going to build, and you'll be able to see how it works. So we're going to build a calculator that's, like I said, very basic. It's capable of adding two numbers together. So we're going to get a number from the user, and then we're going to get another number, two pieces of input, and then we're going to add them together and print out the answer to the user. Okay. So let's go ahead and do that. Why don't we just start completely from scratch? Because sometimes it's a good practice to like rewrite all of this stuff, just get your brain working. So the first thing we want to do, and anytime we get user input, we always want to do this, is we want to prompt the user. So I want to tell the user like what piece of information I'm looking for. Once again, we're building a calculator. So in here, I can say enter first number, and I'm going to put a colon there. And what we want to do then is we want to allow the user to enter their number, and then we're going to grab that number and store it in a variable. And so once again, anytime that we're like getting input from the user, it's always going to come in as a string. So we're always going to get it in the form of a string, even if they enter in like a 4 or a 5 or something. So we're going to call this num1, and I'm going to set this equal to the same thing that we did before. So standard input dot read line sync. And I'm going to make an open and closed parentheses. Good. So now we should have that first number that the user enters stored inside of the num1 field. And if we want, we can just print this out real quick. And I forgot a semicolon here. It's going to yell at me. So we'll go ahead and just print out num1. We'll kind of run this program. Okay, so now I'm going to go ahead and enter the number. So if I entered like a 4, for example, you'll see there that it just kind of prints out the 4. So this is actually working. And we're going to do the same exact thing for the second number. So I can actually just copy all of this code, and I'm going to paste it down here. Now check this out. We'll just say enter second number, and then we'll store this as num2. So we've now gone ahead and gotten the input for the first number, and then we've gotten the input for the second number. We've been able to store both of those in variables, right? num1 and num2. And then the last thing we want to do down here is we just want to print out to the user the result of adding those two things together. So I'm just going to say num1 plus num2. So we're going to print out both of those. And then we'll also remember to add that semicolon at the end. So we're going to run this, and let's go ahead and enter the first number. So maybe we'll put a 5, and then we'll enter the second number, maybe a 10. And now it should add them together and print out the result. Now what you'll notice is that it didn't actually do that. So 5 plus 10 is not 510. And what ended up happening is, remember, num1 and num2 are both stored as strings. And we talked about this before. Whenever you try to add two strings together, it does what's called concatenation. So it takes the first string and then it concatenates the second string onto the end of it. This isn't ideal, right? This isn't going to work for us as a calculator. And this brings us to another really important point, which is called integer parsing or double parsing. Basically, what we want to do is we want to be able to take a string and we want to be able to convert it into a number. So there's a lot of situations like this where we'll get a number, for example, from the user, and then we'll want to be able to, but it's stored as a string, and we'll want to be able to convert that into a number. So let's go ahead and look at how we could do that. So in order to convert a number into a string, there is a method that we can use, or a function we can use. So I could actually say int.parse, and then inside of an open and closed parentheses, I'm going to put the string that I want to parse a number out of. So if I say int.parse num1, this is actually going to take num1 and it's going to convert it into an integer. So whatever number, for example, the 5 that I put here, it'll convert that into a number that we can then add to another number. So I could do the same thing over here, int.parse num2. Now if I run this code, check out what happens. So we'll enter the first number, 5. We'll enter the second number, 10. Now when I hit enter, what's going to happen is we're going to convert this 5, which ended up coming into our program as a string, and then we're going to convert this 10, which comes into our program as a string, into integers, and then we'll be able to add them together, and then we'll be able to use those to do math. Now you can do that with integers. You could also do that with doubles. So down here, now we could add in like 4.5, and we can add in 20.9 or something like that. It'll add both of those together. Now the one thing about this is that you have to enter in an actual number. So if I was to put like hello as the first number and then world as the second, we're going to get this exception because we can't convert hello into a double, we can't convert world into a double. Okay, so this is a really, really, really common thing that we do in programming is we take one data type and we convert it into another data type. Most of the time it's strings to numbers. Sometimes you'll do numbers to strings. So this code is good, and down here we're like using double.parse. That's awesome. We could actually shorten this code though. So I could make this a little bit more concise, and I'll show you how we can do that. So instead of storing these as strings initially, what I could do is I could actually store these as doubles, and I could do this conversion over here on this same line. So I could actually say, I'm going to copy this, and whoops, I could say double.parse, and then inside of parentheses, I can put standard input.readLineSync. Now, as you can see, we're having all these there's all these parentheses here. Like as a beginner, this might start to get a little confusing, but it is good to see this because this is going to be really common. So then we can do the same thing over here. So I'll say double.parse, just like that. And then down here, when we print them out, I could just say num1 plus num2. Like that, and then when I run, if we did 40.5 or 20.9, now it'll be able to add those up, and it's just like a little bit more concise. So we're essentially doing the conversion right after we get the user input, okay? And that's basically how this is structured here. So that's gonna allow us to do that. Cool, so that's our basic calculator, and you could play around with this. So if we wanted this to be subtraction, we could just add the subtraction thing in there, whatever, it would be able to do it just the same. So you can do whatever operation you want. And actually later on in the course, we're gonna look at building this where the user can specify which, like addition, subtraction, multiplication, whatever they wanna do. But for now, that is our first little basic calculator, and that should give you an idea not only of how to get user input, but also from how to convert, for example, a string into a double. Okay, so play around with that if you're still a little confused on it, but otherwise, I think we're gonna move on. So the next thing that we're gonna do is we're gonna build a Mad Libs game. So this is another thing that we're gonna do with user input. I really wanna kind of like hammer this down because this is a really core concept when we're talking about Dart, which is like getting input from a user and then being able to parse through it. That's like half of what we do in computer programming. So we're gonna build a Mad Libs game. If you're not familiar with Mad Libs, I would recommend looking it up. It's a fun game. Basically, you write down like a list of words that could be kind of just random or anything, like adjectives, verbs, nouns, colors, names, whatever. You write those down kind of blind, and then Mad Libs will like sort of intersperse them into a little story, which kind of ends up being funny. I don't know, a lot of people like Mad Libs. I used to love them as a kid. So I'll show you how we can build a Mad Libs game right here in Dart from our program. So with the Mad Libs game, there's two parts to it, right? The first part is we need to be able to get words from the user. So I need to be able to be like, hey, I need a noun, I need a name, I need a color, a verb, whatever. And then the second part is we need to be able to sort of intersperse those random words into a story. So the first thing that we need to do is obviously like get the information from the user. So we need to be able to say, hey, I need a noun, and then get that noun from the user. So we should already kind of know how to do this. And if you want to try to do it on your own, that's fine. But I'm going to walk through all of the steps. So for our Mad Libs game, we're going to get a color, we're going to get a plural noun, and we're going to get a celebrity. So those are the three things: color, plural noun, celebrity. So let's start with the color. I'm just going to create a little prompt here. So I'll say enter a color. And then down here, we're gonna get that input from the user. So I'm gonna store all of these as strings. We don't need these to be numbers, so we can just use strings, but I'm gonna call this color. So once again, I'm creating a variable called color, which is gonna store a string, and I'm gonna set that equal to the user's input. So we're going to say standard input dot read line sync. Okay, so now we're able to get the color from the user. We're storing it in this color variable. I'm going to repeat this process for the plural noun and the celebrity. So here we can say enter a plural noun, and this will be plural noun. Cool. And then once again, I'm just going to paste this down here. You should get in the habit of copying and pasting code like this. This is a perfect example of when we want to copy and paste. I don't want to have to write all of this out again. And since I know this is written correctly, it's just easy for me to copy it and paste it. So then finally, we're going to say enter a celebrity, and then we're going to store this in celebrity. Okay, so we have our color, our plural noun, and our celebrity. We're able to get that info. Let's go ahead and test the program real quick. So we can put like blue, plural noun might be waffles, and then celebrity is like Tom Hanks. So we have all of those things. That looks like it's working. We didn't get any errors. That's only step one though. So the second step to building this Mad Libs game is we have to write out our little story and sort of intersperse each of these in there. So you can make up your own story if you want. I have one written down. So this is a classic. Roses are red, right? And then we can say violets are blue. And then down here we can say, I love you, right? So this is our little poem. Like this is kind of a classic poem. But what I want to do is intersperse the color, the plural noun, and the celebrity in here. So instead of red, we're going to put the color. So we're going to use string interpolation. Instead of violets, we are going to put the plural noun. Okay, and then instead of I love you, it's going to be I love the celebrity. So I'm using string interpolation, which we've talked about, in order to put these variables into these print statements. And now if I run my code, so I'm going to enter a color. So we could say like, I don't know, roses are whatever, yellow. So yellow is our color. The plural noun might be pancakes, and then the celebrity could be Bono. So now you can see we have our little story. It says roses are yellow, pancakes are blue, I love Bono. So this is kind of our little Mad Libs game, and hopefully now you can see how we would do that. So once again, there's two parts to this. We get the information from the user, and then we use that information inside of the Mad Libs. Now, if you're working on this on your own, you can make up your own Mad Libs. You can make this even longer. You could have the user enter in like a bunch of different words. That could be kind of fun. But that should at least give you an idea of how this would work, and then also give us some more practice with the getting user input. Okay, so that kind of wraps up the getting user input section. We're going to come back to this. We're going to keep getting input from the user. This is like the whole, flow of these programs is the user enters something in, and then we use that to do something. So we're going to come back to this, but that hopefully gives you a nice idea of how it works. The next thing that we're going to talk about is a really, really, really core and important concept in computer programming, which is this idea of storing multiple pieces of data. So we've seen how we can store a single piece of data, like a single string or a single number, right? So we have these variables, and the data type is a string, right? So I can say like name is equal to Mike. I can store this in there. In this case, though, we're only storing one piece of data inside of this variable. But in a lot of cases, we're going to want to store multiple pieces of data inside of kind of the same container. And when you have a situation like that where you want to store multiple pieces of related information inside of the same container, we're going to want to use what's called a list or an array. So the words list and array, I guess they technically mean different things, but they're pretty much interchangeable in the context of computer programming. So if you hear someone talking about a list or you hear someone talking about an array, they're generally talking about the same thing. And this is what we call a data structure. So the list is our first big data structure that we're going to be looking at. It's also the most basic data structure in all of computer programming. It is a structure which can store multiple pieces of data. So instead of just being able to store one string, it would be able to store multiple strings sort of side by side. So we're going to look at how we might be able to create an array like that, and I'll show you how it works. So what I want to do is I want to create an array or a container, a data structure is what we call it, that's able to store some of my favorite numbers. And this is going to look a little something like this. So if we wanted to store a normal int, right, I could say my favnum is equal to like 4 or something like that. I would just say int here. But if I want to store these in a list or an array, instead I need to say list and then sort of a less than sign and then a greater than sign. And then over here I can call this favnums. And the syntax is an open and closed square bracket. So in here, I could put some of my favorite numbers. So like 4, 8, 15, 16, 23, 42. So maybe these are like all of my favorite numbers. And you'll see here that I'm storing them inside of this list. So I'm making this open square bracket, this closed square bracket, and then each one of these values is sort of delineated using a comma. So 4, 8, 15, 16. And the data type over here is a list. So we're saying that favnums is going to store a list of integers. And this is generally how we want to how we would want to structure something like this out. Okay, so I'm explicitly telling Dart this is going to be a list that has integers in it. It's called favorite numbers and it has all of these things. Now, you'll hear me using the word list or the word array pretty much interchangeably. I've taught a lot of different programming languages. Some programming languages call these lists. Others call them arrays. Just know that it's the same thing in this context. You don't have to worry. I just might, make a slip of the tongue and call it an array. Now, what we can do with these arrays is we can work with them just like we worked with some of those more primitive values like strings, integers, and Booleans. So I could actually print out one of these. So if I printed out my favnums array over here, you'll see that the computer just kind of prints out that structure. Now, just like strings, these arrays also have index positions, and those index positions also start at 0. So we would refer to the first element in the array as the element at index position 0. The second one is index position 1. This is 2, this is 3, 4, and then 5. So even though this is the first element in the array, it's at index position 0. Even though this is the second element, it's at index position 1, etc. Okay. So this is very similar to those strings. I'm just going to put this on a new line. And so just like with the strings, we can also get a length property. So I could say favnums.length. And this is going to tell me how many elements are inside of it, right? So we have 6 elements technically, right? 1, 2, 3, 4, 5, 6. It's just the last element is at index position 5. And just like strings as well, we can refer to individual elements just like this. So I could say, for example, array at index position 3, and this is going to be the 16. So another thing, just like with strings, we need to get comfortable using these index positions which start at 0. So the fourth element is actually at index position 3, etc. Cool. So all of that, like we kind of seen before with strings, it's very similar. You could actually almost think of a string as like an array of individual characters. There's a lot of parallels there. But another thing we can do with arrays is we can reassign these things. So for example, I could come down here and I could say favnums at index position 3, and I could actually change it. So I could change it from 16 to like 17 or something like that. So if I do this and then I go to print out favnums 3, you'll see that it actually changed to 17. And if we print out the entire array, I've actually modified element at index position 3 so that it's 17. So anytime you want to access one of the elements that's inside of the array, you do it like this, and you can reassign it. You could also use it in operations. So I could say, for example, favnums 3 plus favnums 0. So that's going to end up being 17 plus 4, because 4 is at index position 0. And then we should get 21 out here. Okay, so with these arrays, yes, they're storing all of these elements side by side, but we're also able to access individual elements as well. And that's just like super common, something that you're going to be using all the time when you're coding. Okay, so we talked a little bit about the index positions, about the length, and about accessing individual elements. There's also some other things that we can do. So for example, I could say favnums. If I want to add an element to this, I could say favnums.add. And then in here, I can put a new element. So let's say I wanted to add in, like 64 into this, right? What this will do is it'll essentially add this element onto the end of the array. So if we print out favnums, you'll see instead of ending at 42, now it ends at 64. So we've sort of appended this element onto the end. Once again, this is super, super common, super useful. There's some other things that we can do as well, though. You could also remove an element. So if you wanted to remove a particular element, you would just have to refer to that element. So I could say here, I want to remove element 16. That'll actually end up removing this from the array. So now if I was to print out the array, you'll see that we no longer have 16 there. That's been removed. And there's some other more, I guess, complex ways that we can go about removing things from an array, but this is definitely the most common. We call this removing by value. So whatever element has the value 16, that's what gets removed. And you can play around with these, create your own array and do all sorts of stuff. But I think that's probably good for that. Now, there's a couple other ones that I want to show you, and these are pretty similar to the things that we could do with strings. So just like with the string, we can also say index of, and in here we could put an element. So I could say like 15, for example, and this will tell me at what index position 15 shows up. So we should get 2 back, right? Because 15 is at index position 2. Now, one thing to note is that if you put an element in here that doesn't exist in the array, so if I put a 40 in here, like there's no 40s in this array, it's going to give me a -1 back. And this -1 is just an indicator that it doesn't exist in the array. That kind of lets us know. So you can say index of, that'll give you that index back. That's pretty common. And then another one, just like with strings, is contains. So I could say contains 15, and because the element 15 is in here, we should get a true back. If I was to say, 18, though, that's not in there, so then we should get false back, okay? So these are the same methods that we used with the string. These are the most common, and it's very similar to strings. Now, you can have a list of integers. You could also have like a list of strings. You could have a list of Booleans, whatever you want to have, but you just have to make sure that they're all added in over there. Cool. So that's a little bit about arrays. We're going to get more into using arrays a bit later, but like I said, this is the most common data structure. So this idea of a data structure, it's a way that we can structure the different data in our application so that it's more organized. The array or the lists, and I'm using those terms interchangeably, those are the most common. Okay. Cool. So the next section then, we are going to be introducing another just like super core concept in computer programming, which is called functions. And you've heard me talk a little bit about functions in the past. So we talked about how like this main thing, this is actually a function, okay? We've also talked about how something like contains, this is a function. So what are these functions? Like what can we do with them and how do they work? Now, before we get into this, I do just want to make another disclaimer. A lot of times in these programming languages, we have multiple words for things. So just like with arrays and lists, how they're kind of the same, basically the same word. In some programming languages, there's a distinction. The word function and the word method are essentially interchangeable. There is like a technical difference between the two, but in this context, if you hear someone say method or you hear someone say function, they're pretty much referring to exactly the same thing, okay? So just so you have that in mind, like if I use the word method instead of the word function, I mean exactly the same thing, okay? It's just like a little terminology. So what is a function? Well, a function is a collection of code which can be reused multiple times. And this is just so foundational to computer programming. We have this concept in computer programming called the the don't repeat yourself principle. And they call it like the dry principle, don't repeat yourself dry. And it's basically this idea that if you write code that can be used in multiple places, you only want to write it once and then you want to reuse it throughout your program. So I'm going to show you an example of this real quick, and we'll kind of build this up slowly so we can get a feel for these different functions. Now, if you remember before, we had this little triangle that we printed out. So I'm actually just going to real quick kind of do this. We'll make this kind of a really tiny triangle. So we can print out a little triangle here, and then this guy is going to go there, and then we can have some underscores. Okay, so this is like a really basic version of that triangle that we did in the beginning of the tutorial. So if I print this out, I get it here. And let's say though that instead of printing out one triangle, I want it to print out like 5 triangles. So I don't just want 1, I want 5. So what I could do, and this is all we've learned so far, is I could just do this 5 times, right? So print this out 5 times. It's obviously not formatted correctly, but I could run this, and now, booyah, we got 5 of these triangles that are printed out. Now this is okay and it works, right? I mean, technically we fulfilled the goal, right? I mean, we printed out 5 triangles, but look at this code. I mean, first off, not only do we have 5 times the amount of code that we had with this first one, but we're also repeating ourselves. We're using these same 2 lines of code over and over again. And so once again, just like with those variables, imagine that I wanted to change the way the triangle looked. Maybe instead of being a triangle, I want it to be like a square now. So I wanted it to look something like this, whatever. Like maybe this is the new shape that we want to use. Now I need to essentially go through and change each and every one of these individually and hope that I don't mess up so that I can get 5 of them. This is a perfect example of a situation where we want to use a function. It's when we have code like this, like this little triangle, that we want to reuse multiple times. And so let me show you just real quick how we could put this into a function so that it's more reusable. Now, when we declare these functions, we're actually going to put these outside of this little main function. So you can put them in the main function too, but it's just better to put them outside. And there's going to be some syntax here that you're not going to understand. I'm going to explain it, so don't worry. But for now, whenever we create a function, we're going to say void, and then we're going to say the name of the function. So in this case, why don't we call this draw triangle? And I'm going to make an open and closed parentheses, and then I'm going to make an open and closed curly bracket. Now, you don't need a semicolon after this. So anytime you have these like curly brackets, you generally don't need a semicolon. But what I'm going to do then is I'm going to take this triangle code and I'm going to put it in here. Now check this out. This right here is what we call a function. This is a container that holds a collection of code that we're able to reuse multiple times. So because I have this inside of a function now, instead of me having to print out all of these triangles individually, I can do what's called calling the function. So I can actually call this function, and what that means is that the program is going to go over, it's going to run all of that code, and then it'll sort of hop back. So let me just show you real quick. We can use this to draw 5 triangles really easy. So I'm going to take this line of code, and I'm just going to put it down here 5 times. It's 3, 4, 5. Okay, so these are all down here, and cool. So now if I run this, you'll see that we have 5 triangles that should show up. And so right there, you can see all the triangles print out. It's exactly the same output as we got from the code before. It's just now we don't have to repeat ourselves. And what's cool about these functions is that if I want to try and change this, so if we wanted to change it to that square, right, the square that we had before, I can do that in one place. And now it's going to update for all of these. So you can see now we're printing out all of those squares. Okay, so that's the basics of a function. It's a container where we can put code that we want to reuse. And whenever we want to use that code, we can just call the function like that. And to call the function, you need to put this open and close parentheses after it. Now, I want to highlight another point real quick, which goes back to the execution flow of our program. If you remember before, I talked about how we execute one line of code, right? And then we go down to the next line, and then we go down to the next line. When we're working with functions, it's a little bit different. So let me just demonstrate this real quick. I'm going to make 2 print statements. This one's going to be called before function. And then we're going to make another one down here, which is called after function. So let's take a quick look at what's happening in the execution of our program. So I'm going to run this, and you'll see that it says before function, then we print out our square, and then it says after function. So the way that the computer's executing this is, once again, it's always going to start in this main function right here. So this is always going to be the entry point for our program inside of main. So the computer's going to go down, it's going to see, okay, here's this print statement. I'm going to print that out here onto the console. Then it's going to see that we want to execute this function. And when it sees that we want to execute a function, it's going to go and it's going to jump over to the function, and then it's going to execute each line of code in the function in turn, just like we talked about before. And then once it's finished executing the last line, it's going to come down here and it'll move on to the next line here in main. And that's exactly what you're seeing, right? So we have before func, and then the computer jumps over to this function, executes all the lines of code inside of it, and then jumps back down and continues on with the execution of the main function. So functions, there's basically like the computer will just jump over to them, execute the code, and then sort of come back. Okay, and that's really how these work in the execution flow of the program. All right, so that's a little bit about the basics of functions. We've talked about how they're just sort of these reusable containers, but these can get a lot more powerful. And the way they get more powerful is through something called parameters and arguments. And parameters and arguments are essentially the same thing. It's another one of those things where it's like two words. Technically, they are a little bit different, but a lot of people use them interchangeably. And these allow our functions to just be so much more powerful and reusable. So I want to show you how this works. Let's just get rid of all this code, and we're going to start kind of from scratch here. I'm going to create a function which is able to say hi to a user. Okay, so this is gonna be a very simple function. Once again, I'm gonna say void, and then I'm gonna give this a name called say hi. I'm gonna make an open and closed parentheses and an open and closed curly bracket. Now, we could have this function here, and all it does is it could just say hi Mike. So it'll say hi to me. And then down here, I could execute this, right? So boom, just like that. And then it'll go ahead and say hi to me. And I could run this, multiple times. Like I said, this is really reusable, and it'll do that 3 times. But let's say that instead of saying hi to Mike, I wanted this to be able to say hi to essentially any user or any username that we could imagine. The word Mike is kind of hard-coded here into this print statement. I can't change it. And this is a situation where we would want to use parameters and arguments. So a parameter is a value that we specify that the function needs to do its job. So sometimes with these functions, they're going to need pieces of information, values, in order to do the job that they're sort of assigned to do. And those are called parameters. So the parameters are all the values that the function needs in order to do its job correctly. Now in this case, we could define a parameter, which is called username, and the function will use that and it'll say hi to the username. So let me show you how to do that. Up here in this open and closed parentheses, this is where we're going to define all the different parameters, all the different pieces of data that the function needs to do its job. And the first one is going to be a string, which is called username. So that's just going to go right here. And this is me defining that this function needs something called username. And so down here, I'm actually going to use string interpolation, and I'm going to interpolate that into here. So this parameter is what we call it. It's basically a variable. It's literally the same thing. We're just calling it a parameter because it's part of a function. It's not just sort of like free floating. But you can use this, you can think of it exactly like the variables that we've been looking at. Now check this out. Because I've specified that this function takes a parameter, if I try to run this, you'll see that we get an error. It says too few positional arguments, 1 required. All that means is that I've specified that say hi needs a username parameter to do its job. And so when I call the function, I have to give the function that piece of information. And this is what we call an argument. So an argument is basically a value that's passed in and gets stored as a parameter. And like I said, they're pretty much the same thing. There's just that small distinction. So what I can do here is I could say hi Mike. And now if I run this program, it says hi Mike. I could also copy this, and instead of saying hi to Mike, we could have it say hi to Joe. So hi Mike, hi Joe. It's doing both of these. Now, what's happening here is we're calling the say hi function. The say hi function is specifying that it needs a username to be able to do its job. So we're going to pass in a username, which is a string, into the function. So in this case, when we call say hi, this value Mike is going to get stored inside of this username parameter, and then we can use that just like a variable to do string interpolation and to say hi to the username. And this is really powerful because now we can tell the function what the name is that it should say hi to. We now have control over the input into the function. So I can say hi to Joe, I can say hi to Mike, and it's able to do both of those. So this function just became a lot more flexible because now it's able to take in arguments or it's able to specify parameters here. It's the same thing. And then it's able to use them. Okay, so that's really the main use case of these arguments and parameters. So the argument is the value that gets passed in. The parameter is sort of the value that we specify up here. That's really the only difference. Now you can have one argument, or you can also have multiple arguments and multiple parameters, right? Same thing. So let's say that in addition to the username, I also wanted to specify an age. And the age is going to be an integer. So I can say, okay, the first parameter, the first value that this function needs to do its job is the username. The second is this integer, which is called age. And over here we could say, hi username, you are, and then here we can interpolate the age. So now if I run these, you'll notice that we get another error. And I'm sure you can guess why. It's because we've specified that say hi needs 2 values to do its job. But down here, we're only passing in 1. So now I have to pass in like the age, and then, maybe this one's 50. And so now because we're passing in these 2 arguments, the program is able to do its job. So we call these like positional parameters or positional arguments. They're basically separated by the comma. This is the most common way to do this. There's some other ways to pass in arguments as well, but this is really like the most basic. This is what we're going to be using. So that is a little bit about arguments and parameters. And as you can see, it makes these functions just like so much more flexible because we can change up all of this data. All right, now believe it or not, that's not everything with these functions. There's another concept that we need to talk about, which is this idea of a return value. So functions, like these functions that we're using right now, all they're really doing is just like printing stuff out, and that's fine. Like that's a good function, but just like we can give functions information in the form of arguments and parameters, we can also get information back from functions. So we can call a function, it can go and do a bunch of cool stuff, and then it can actually give us a piece of information back that we can use in our program. And this is through what's called a return statement. So we're actually gonna look at another example. I'm gonna get rid of this, and we'll look at how we can use return statements. Now, you'll remember that when we've been creating these functions up to this point, we've been using this void keyword, and that's also what's used here in main. So we could say void, and then I'm going to create this function. It's going to be called add numbers, just like that. Now, this void over here is what we call the return type. And the return type is a specification of what data type this function is going to return. Now, up until this point, we've been writing functions which have returned void. This void data type basically means that the function is not going to return anything. It's not going to return any value back to us. But now that we're talking about return statements, I want this to be able to return back to me a double. So we're going to write a function which is able to add 2 doubles together, and then it's actually going to return the answer from adding those together back to us. And I'll kind of talk through how that works. So this add numbers function is going to take 2 doubles. So the first is going to be num1, and the second is going to be num2. And then I'm going to use this special keyword, which is called return, and then I'm going to return num1 plus num2. So this function is very simple. We just take in these 2 numbers, and then we return the result of adding them together. Now let's see what happens if we execute this program. So I'm going to call add numbers, and let's pass in 5, and then we'll pass in 10. So I'm going to run this, and you'll notice that nothing actually shows up over here on the console. We're not printing anything, we're not doing anything, we're just calling this function. So you're probably thinking like, what's the point? Like, I don't get it. What's actually happening here? Well, if we go ahead and print out the result of calling this function, so we're going to print out the result of calling add numbers, I'm going to run this and check out what happens. We actually get the answer back. So what's going on here is whenever we have this return statement and we call this add numbers function, this is essentially going to get a value returned back to it. So as far as Dart is concerned, we call add numbers, and then this ends up becoming the value of whatever got returned. So add numbers now is going to be sort of executed, and then this result is going to end up getting printed out. This is sometimes a little bit hard to understand. I'm going to show you another example of like how this kind of works. So we could create a double over here called answer, and I'm going to set this equal to the result of calling the add numbers function with 5 and with 10. Now check this out. If I was to print out the answer, we should get 15 again. So when I call this, it essentially becomes the value that gets returned from the function. And so the value that gets returned from the function is what ends up getting stored here in this answer double. So that's kind of how this works. And this is really useful because a lot of times, like, we're not just going to be printing out the answer to something like we've been doing in the past. Most of the time, we're going to write these functions. They're going to return values back to us, and then we're going to store them inside of like variables, or we're going to use them in some other way, shape, or form. So that's like a really important concept in these functions. Okay, so that is the return statement. And that's really nice. Now, one thing that you need to be aware of is that the return statement should always be the last line of code. So this is a really simple function, and we're going to look at some more advanced ones later. But like, if I had this, like, I'll print out before return, we'll put our semicolon, and then over here I'm going to try to print out after return. And I wouldn't be surprised if we just get yelled at for doing this. But let me show you what happens. Okay, so we didn't get yelled at, but look at what happens, right? So we run this add numbers function. Okay, we print out before return, and then we print out this 15, which is actually down here. We never end up printing out after return. And that's because this return keyword is going to break you out of the function. So we talked about the execution flow of programs like earlier. The execution flow for this is that we call add numbers, we print out before return. When Dart sees the return keyword, it's going to return this value back to the caller, and then it's going to stop executing the function. So we'll never actually get down to this line of code. So you never want to like put code after the return statement because it just won't get executed. Okay, so that's a little bit about return statements. Now we're gonna build another function which is using these same concepts, just to kind of drill this in your heads a little bit more. So we can go ahead and get rid of all of this. Now I'm gonna create another function which is called prompt. Now if you remember before, when we were writing all this code, like when we built the Mad Libs game, right, we had the text here, so like enter a color. And then we also had, where we're saying like, okay, so we have a string, which is called color, and that's equal to the standard input dot read line sync, right? We're doing all of this. So there's this whole process where I had to prompt the user, and then I had to like get the input from them like on the command line or whatever. So this is actually something that could be put into a function, because remember, we had to reuse it. So we had this same thing for like this celebrity, right, whatever. So there's this same code that we were repeating. We could take this and we can put it into a function, which would end up allowing us to reuse it. So let's take a look at how we could do that. So up here, we're going to create another function, and this is going to be called prompt. Now I'm going to give this a return type. So this is actually going to return a string. The last function that we used returned a number. This one's going to return a string. So we have the return type, which is string. I'm going to call this prompt. And this is going to take one parameter, one argument, which is going to be a string, and it's going to be called prompt text. Okay, so remember we talked about these parameters, right? We can use that. This is a value that the function needs in order to do its job. And then down here, we're basically going to write that same code that we were writing down here. So instead of me printing out like enter a color or something like that, instead I'm going to print out the prompt text. And then maybe over here we can put like a colon. So I'm using string interpolation. And actually, we don't even need to use string interpolation. We could just type out prompt text. But basically, I'm going to print out the prompt text. So this would end up being like, what's enter a color, enter a plural noun, enter a celebrity, whatever. So we're going to prompt the user, and then we're going to create a string called answer. And we're going to set that equal to the standard input dot read line sync. And then finally, we're going to return the answer. So these 3 lines of code, we prompt the user. Okay, we get their answer and then we return it. Now check this out. All I have to do now if I wanted to get the color, so I could say string color is equal to, instead of me having to go through this whole process where I prompt the user and then get the answer, all I have to do now is I could just say prompt, and in here I just need to pass in the prompt. So I could say what's your, or sorry, we'll say like enter a color, right? Enter a color. Boom. And then that'll end up being stored in there. So then we could print out like the color is color. So now when we run this, because we're using this function, if I want to do this, then we'll actually be able to reuse all of this. So we run this, it says enter a color, so we can enter in blue. Now, what's going to happen is that blue is coming in from the standard input. It's going to get stored in this answer variable, and then we're going to return that. That's going to end up getting stored in this color variable. You can see this is like maybe a little bit hard to follow now. So I'll hit enter on here, and then you'll see here it says that the color is blue. Now the reason this is so useful is because now if I wanted to get like the color, and I could also get the, what is it, plural noun. So enter a plural noun, and then we could do the same thing for celebrity, right? So all, like before, this would have taken a bunch of code and we would end up reusing a lot of code. Now I can do this in just like 3 easy lines of code, and it works out. Okay, so this is why it would be like really easy for us to, or it'd be really good for us to put this in a function, because then we can reuse it. And once again, if I wanted to change this, I could change it really easily. So maybe we wanted to change like how the prompt text was displayed. So I could say like the prompt is prompt text. And now this will actually change it for each one of those. So now if I try to run this, it says the prompt is enter a color, so blue. The prompt is enter a plural noun, whatever. So we could go through that whole process. And it's just really easy. So really like the main point of these functions is that you define the code once and then you reuse it multiple times, just with different arguments, parameters, different values that it needs to do its job. And it just makes them so much more reusable. Okay, so we've covered most of the basics with functions, and really like this is all functions are. Like you can add more parameters and arguments, they can become more complex. But at the end of the day, these are the core concepts. And so the more functions that you write, the more comfortable you'll get. But really the big thing with functions is just being able to determine which code should go into its own function and which code shouldn't, like basically how those things are organized. And that's something you'll pick up as you continue programming and as you continue watching other people program and stuff like that. But I think that kind of wraps up our little section on functions. Now, the next thing that I want to teach you is actually going back to those Booleans that we looked at in the beginning of the video. And we're going to be looking at something called conditionals or if statements. This is another one of those like the programming bread and butters, like one of those things that you're just going to be using all the time when you're coding. And it's such a core fundamental concept. So I'll just be walking you through exactly how that works. Now I have an example here of some if statements. So an if statement is a way in our computer program, right, where we can give it some intelligence, some logic. So it's these if statements that allow us to allow our program to make decisions. So if you add in if statements into your code, then it's able to pick and choose and decide what it should do based on the inputs and the data that your program has. So that's really what we're doing here. We're sort of injecting some intelligence into our code, and I just want to give you kind of an idea of what these if statements are at a high level. So believe it or not, as a human being, every day you are dealing with if statements. You are actually kind of an expert at these if statements. It's just now we need to be able to translate them into something that the computer can understand. So here we have an example of some if statements that you might encounter every day. So here it says, I wake up, if I'm hungry, I eat breakfast. So this right here, perfect example of an if statement that a lot of us encounter every morning. So we have a situation, right? We have a particular set of, things that are going on in our life, right? I wake up, and then here's the if statement. It says, if I'm hungry. So we're saying if, and then over here we have what's called a condition. And the condition is whether or not you're hungry. Now this can be true or false. So if you're hungry, that means that this is true, and that means that you're going to come down here and you're going to eat breakfast. Now, if this is false, so for example, if I'm hungry is false, that means that you're not going to eat breakfast. You're going to completely skip over that, and you're going to just kind of keep going on with your day, right? So perfect example of an if statement. And to kind of break this down, we have what we call the condition. This is either going to be true or false. And if it's true, then we run this action, right? You eat breakfast. Otherwise, you just ignore it and you move on with your day. So there's another one down here. It says, I leave my house. So this is like our situation. And then we have an if statement. It says, if it's cloudy. Now, once again, it's cloudy. This is a condition. This can be true or false. If there's clouds outside, then it's cloudy. If there's not clouds outside, then it's not cloudy. If this condition is true, then we're going to come down here and we're going to bring an umbrella. Now, this one's a little bit different because you see down here it says, if it's cloudy, I bring an umbrella. Otherwise, I bring sunglasses. So this condition up here, if it's cloudy, if that's true, that means we're going to bring the umbrella. But if this is false, that means that we're going to bring sunglasses. So there's this otherwise keyword. In programming, we call this the else keyword, which is going to sort of add in something that we should do if the original condition isn't true. Okay, and then finally, we have one more if statement down here. It says, I'm at a restaurant. If I want meat, I order a steak. Otherwise, if I want pasta, I order spaghetti and meatballs. Otherwise, I'll order a salad. So this is even more complex than the previous one. So we have our if statement, right? If I want meat. Now, if this is true, then we're going to come down here and we'll order a steak. But if this is false, it says otherwise if I want pasta. So in this case, there's actually another conditional that we can look at if I want meat is false. And if you want pasta, then you're going to order spaghetti and meatballs. And then otherwise, if you want neither steak or if you want neither meat nor pasta, then you would come down here and order a salad. So this is like these three if statements. Obviously, like this one's super simple, and then this one down here is like a lot more complex. These represent the different types of if statements that we're going to have in our computer programs. It's just instead of us as humans, looking to see if it's cloudy and bringing an umbrella, we're going to have the computer do some stuff. But hopefully this gives you an idea, right? There's some intelligence in this, right? We're checking, is it cloudy? And if it is, then we need to do something like bring an umbrella. Otherwise, we'll do something else. So there's like decision making that's sort of being injected into this. And that's what we're going to look at with our code over here. And I just want to move that. Okay, so let's go ahead and get rid of all of this stuff. We want to just kind of clear all of this out. And actually, I'm going to keep this prompt. So we're actually going to end up, I think, using this a little bit later on. So I'm going to keep this. You can just put this down here at the bottom of the file, just so it's kind of out of the way, but we're going to bring that back. So if you want to keep that, then I would recommend doing that because I think we're going to use it again. So now that we're talking about if statements, and like I said, the if statement has two main parts. There's a condition, which is true or false, like if it's cloudy, and then there's an action that we want to take if that's true or if that's false. So let me just show you real quick how we write out an if statement. So you can just say if, an open and close parentheses, and then an open and close curly bracket. And this is like the standard syntax for writing if statements. So in here, we're going to put our condition, and then down here, we're going to put our action. So this needs to be a Boolean value. This needs to be either true or it needs to be false. Now check this out. I'm going to make this true. Okay, so this is what we call our if condition. And then if this is true, then we'll come down here and we will print something out. So we could say it's true. And apparently I can't type that. So now when I run my program, check out what happens. It's going to execute this code. It's true. So the computer goes down, it sees this if statement, and it looks at the Boolean value here. It looks at like the condition. If this is true, then it's going to come down here and it's going to print this out. Now, if I move this to false, check it out. I'm going to run and you'll see that nothing gets printed out. And that's because this is false. So whenever the condition that's inside of these parentheses is false, this code doesn't get executed. Whenever it's true, the code does get executed. And that, in like a nutshell, is how if statements work. Now, these get a little bit more complicated. So for example, let's say when this is false, I want to do something, right? So when this is false, I want to do something. That's where we can use this else keyword. So this else keyword is the same as that otherwise. You know, it's like if it's cloudy, I bring sunglasses. Otherwise, if it's cloudy, I bring an umbrella. Otherwise, I bring sunglasses. Same thing. So that's just else is another word for otherwise. So down here, we could say it's false. Cool. So we can run this and you'll see now it says it's false. If I was to change this to true, then it becomes true. So if the condition up here is false, then we're going to execute whatever's in the else. If it's true, we execute whatever is in the if, okay? And this syntax here is like pretty standard. So what I would recommend doing is just play around with this if statement structure, because being able to wrap your head around like how this works is so important in computer programming. I can't stress enough how much people use conditionals. So there's some other things that we can do with this as well. So almost never are you just going to be putting it like true or false directly into here. It doesn't make any sense. But what we will do is we will use this when we're working with variables, particularly with Booleans. So I could create a Boolean over here called isSmart, and I could set this to true. And I could actually use this Boolean here as the condition. So I could say if is smart, then down here we could say you are smart, and then down here this would mean that they're not smart, so we can say you should study more. So let's run this, and you'll see here because the value of this Boolean is true, then we execute this. I could change this, and then you can see over here that that works. So with the conditionals, we just need some sort of a Boolean. And we talked in the beginning of the video about how, like, yes, we can use true or false values, but we can also use comparisons. So I could say like 5 greater than 3 in here. This can actually get reduced down to a Boolean. So this 5 is greater than 3, that's true because 5 is greater than 3. So this actually ends up becoming like a Boolean value, you can say, and you know, obviously the text doesn't make sense, but we could put Booleans in here. We could also put like these little expressions. And like I said, with these, we call these comparison operators. You can do like greater than or equal to, less than or equal to. You can also do equals, which is just this. So in this case, like 5 equals 3, that's going to end up being false. Whereas we could say 5 equals 5, and then that's going to end up being true. Okay, so that says you are smart. There's another one as well, which is this, if you say like, this is called the negation operator. You could say not equals. So this would be like 5 is not equal to 5. So I would recommend just like playing around with all these operators, like see how they work. And it's really easy to see that in the context of these if statements. Okay, so we could just have like a Boolean there, like is smart. Another thing that we could do as well is we could have like, so one of the things we saw like in the beginning of the video, we had this greeting. So maybe the greeting is like hello. I could use, if you remember, we could do something like, we could say, you know, greeting dot contains an E. And we saw that this is going to end up returning a true or false value. Like if the greeting contains the letter E, then this will be true. If it doesn't contain the letter E, then this will be false. So this is another thing that you could do, right? Is like, you could say something like this. So the greeting has E in it, and then this would be the greeting has no E. So now if I run this, you know, you can see over here, the greeting has E in it because we're using this. So inside of, I guess the point I'm trying to make here is like inside of these, inside of this like if statement conditional, there's a lot of different ways that you can get to a true or false value. You can do comparisons. You could just have straight up Booleans. You could use some of these like string methods, but either way, we need to get down to a true or false value while we do that. Okay, so that's a little bit about like if else, and this is just the basics of if statements. So we have if else like that. Now, another thing that you can do, if you only have one line of code inside of the if statement, and this only applies if you have one line of code, which is sometimes pretty common, you can actually get rid of these curly brackets. So I could do something like this only when I have one line of code. So you could say, and my text editor is wrapping a little, but we could say something like, you know, if, and let me format this, if greeting.contains E, print this. Otherwise, so just with the one line of code, we're able to do that. But generally, like, it's a good idea to just put the curly brackets around. but you will see people like omitting them. Cool. So I want to talk about some more concepts with this as well, because those if statements are pretty basic. We're just checking like one condition and then otherwise we're doing something else, but these get more complicated. And I also want to introduce to you two operators called the and the or operators. And these make your if statements just like so much more powerful. So in order to demonstrate this, we're going to create two Booleans. So one is going to be called is smart, and we're going to set that equal to true, because I'm pretty sure we're all pretty smart if we're learning to code. And then we're going to say is student, which is also going to be true. So we have two pieces of data now that we're working with in our program, is smart and is student. And this tells us, let's say we have a user, right? Are they smart and are they like currently a student? And we can use this information in order to help our program make decisions. And that's really what these if statements are for, right? It's we have different pieces of data that we're working with. We're always working with data when we're doing computer programming. And so we have these two pieces of data, and depending on the value of these two pieces of data, we want to do different things. So for example, like here we have two pieces of information. So there's like almost 4 different combinations that we could make, right? They could be smart and they could be a student. They could be smart and they could not be a student. They could be a student and not be smart, right? There's all these different like cases that we might want to account for in our program. And the if statements are perfect for that. So let's go ahead and write an if statement block that's going to be able to check all of those things, okay? Now, first off, we're just going to check, so we can say if is smart, and what I want to do is I want to check all those different combinations. So I want to check, first and foremost, are they smart and are they a student? Because that means they're like a smart student, for example. So I'm going to say is smart, and then I'm going to use this special operator called the and operator. And it's just a double ampersand like that, and then is student. Now, the and operator is really, really important. It's actually super fundamental to even just the way that the computer works, like at a hardware level. There's these things called like AND gates. It's like AND based logic. We don't need to worry about that, but there are these two values that we want to check. And this condition is only going to be true if they are both smart and they are a student. So anytime we use this AND operator, it means that this needs to be true and this needs to be true, and then the whole thing becomes true. So check this out. Here we could print out you are a smart student. Because if this line of code down here executes, it means that they are both smart and they are a student. So let's check this out. Right now, they're a smart student, so we could run this, and it should say that. But the second that one of these becomes false, so if is smart becomes false, now all of a sudden you'll see that we don't print anything out. Or if this is true and this is false, now you'll see that we also don't print anything out. So this AND operator allows you to check multiple conditions, multiple Boolean expressions, right? You can check two things together, and they both need to be true in order for the whole thing to be true. If one of these values is false, like if they're not a student or they're not smart, then the whole thing becomes false. And that's just the way that sort of AND logic works, okay? Now, there is another operator, which is very similar, and that's called the OR operator. And it's just these two vertical bars. And that should be, well, I'm on a Mac. It's right above the return key is that like little vertical bar. I think they call it the pipe character. I don't know. But this is similar to AND, but it's a little bit different. So the OR operator only needs one of these things to be true for the entire thing to be true. So if we're using the OR operator here, instead of saying you are a smart student, we could say you are either smart or a student or both. These are all the conditions where this could be true. So in this case, they're smart and they're a student. The OR operator is going to say you are either smart or a student or both. If one of these is false, you'll see that it still runs that code. And that's because with the OR operator, only one of these needs to be true in order for the whole thing to be true. So if I made is smart true and I made is student false, you'll see that the whole thing still becomes true because one of them's true. If these are both false, that's the only situation where it's not going to run. You can see there we didn't run that code. So with the AND operator, both of these need to be true in order for the whole thing to be true. With the OR operator, only one of these or both of them needs to be true in order for the whole thing to be true. And this is like, we call this and or logic. It's like super, super fundamental to computer programming. There's some other logic too, like XOR logic and stuff. I don't know. You can look that up if you want, but this is what we're using 99% of the time. Okay, so that hopefully gives you a little idea about these operators. Now, I want to continue on with this example. So we're using the AND operator, which means that if this is true, it means that you are a smart student. Okay, I'm going to keep using the AND operator, but you could also do this with the OR operator. It would just be a little bit different. So in this case, we're checking the condition where they're both smart and they are a student. But let's say that we also wanted to account for all the other situations as well, like maybe they're a student, but they're not smart. Well, in order to do that, we need to check another condition. And sometimes in computer programming, we're going to want to be able to handle multiple combinations of these different Boolean values. And whenever multiple conditions basically. So in order to do that, we can use what's called the else if. So you can just type in else if, and I'm just going to write this out and then I'll explain to you what's going on. So I'm going to say else if is smart and exclamation point is student. Now I know there's some new syntax here. Just give me 1 second. So I'm going to print this out and it's going to say you are smart but not a student. So look at this right here. This else if is very significant because what's going to happen with the flow of the program is when Dart first goes through and is looking at this, it's going to look at this condition first. And it's going to say, okay, are they smart and are they a student? Now, if that's true, Dart's going to come down here and it's going to print this out and then it's going to break out completely from the if statement. It's going to be completely done with the if statement. If one of these ends up being false though, so if this whole condition is false, instead of breaking out, Dart is then going to go down to this else if and it's going to check this condition. So the else if only gets run if the condition above it, like in this if statement, is false. That's the only situation where this is going to get run. And you'll notice that this could also be false, right? That's technically possible. Okay, so we're going to keep looking through this, but just stick with me for now, and this should all start to clear up a little bit. So in this else if, we're checking to see if they're smart and you'll notice that I'm using this exclamation point. So we just kind of talked about this. The exclamation point is what's called the negation operator. And maybe I can just show you guys this real quick. So here I'm going to print something out. So I'm going to print out true right here, okay? So we'll print out true. We're going to put that semicolon in there. Not going to forget that. When I was planning for this thing, I forgot semicolons almost every time. So I was kind of worried, and you can see I forgot one there too. Just not used to using them. So, okay, we're printing out true here, right? Now, if I put this exclamation point right next to it, what it's going to do is it's going to negate that value. So it'll basically turn it into the opposite value. And with Booleans, true is the opposite of false, false is the opposite of true. So if I do this now, you'll see that we get this false. So this is just a really easy way to negate something. And we use that a lot. So you can see down here, the situation where we want to negate this is essentially me saying that they're not a student. So if they're not a student, then this ends up being true. This Boolean logic takes a little bit to wrap your mind around. So if I were you, I'd just play around with it a little bit just to kind of internalize it. But essentially what we're saying here is that they are smart and they're not a student. That's what that negation operator is doing. Okay, so then down here, this is appropriate, right? We could say you are smart, but you're not a student because that's what this condition is sort of encoding. So let's see if we can get that one to trigger, right? So that would mean is student should be false, but smart should be true. And if we run this, now you'll see that that works. So really what the code is doing is it's looking here. So the first thing it does is look at the first condition. This ends up being false, right? Because they're not a student. Then we come down here and we check this condition. If this is true because they're not a student and they're smart, so then that's the situation that gets executed. Now we can keep doing this for the other situations. So there's another situation here where we can say they're not smart and they're a student. Right, so this is the situation where, okay, they're kind of like I guess a dumb student, right? That's really what we're saying here. So we can say, you are not a smart student. So that's like technically what we would want to encode there. So let's see if we can get this one to trigger. So I'm going to change is student to true. I'll change is smart to false. And one more time, I'll kind of run you guys through what's going on. So it says you are not a smart student. It worked the way we wanted it. So Dart looks at this first condition. This is false. And so that it moves on to this else if. It checks this condition next. That's false. So then only after these two are false does Dart move down here and check this one, right? So these both need to be false before we even check this. And if one of these ends up being true, then we just break out of the entire if statement. Cool. And then finally, there's that last situation. Now in this case, we can just put this else because there's only one more possible situation, which means you are not smart and not a student. So that's right there. And so then that would be when like both of these are false. So you can see that's the situation down there. Now you could put another else if in here, right? You could say not is smart and not is student, but it's kind of unnecessary because if it's not any of these three, then it has to be the other one, just because like there's no other possible combination of these two. So I'm fine with just putting the else here. I like that. And we'll run this just to make sure it's working. Cool. So this situation, as I've said before, very common where we have pieces of data and depending on the value of those pieces of data, we want to do different things. So this is essentially our computer just making decisions. That's all we're doing. And there's some other like types of things you can do with this, but this is bread and butter. This is like down and dirty, just basic if statements. So, okay, I'm pretty happy with this. I think now we can move on. So the next thing I want to do is use these if statements to make one of our other applications a little bit better. So before we built this calculator was pretty cool, but one of the downsides of the calculator that we built was that you could only add the two numbers. So I would enter in one number, I'd enter in another number, and then those two would just automatically get added together. I wasn't able to specify whether I wanted them to be divided or multiplied, subtracted, added, whatever. I didn't have choice. And now because we have these if statements, we can allow the user to make that choice, right? We can actually respond to the different data. So we could say like, okay, if they want subtraction, then we'll give them subtraction. If they want addition, we'll give them addition, etc. So we're going to go ahead and just kind of, I guess, like code that in. That's what we're doing now. I also want to bring in some of the other concepts that we've used just to kind of start combining all of these things together so you guys get a better idea of how it works. So the first thing that I would like to do, and this is, again, part of our more advanced calculator, is down here we have this prompt method or this prompt function. And I'm actually just going to copy this. So if you hopefully you saved this from before. If not, just copy this out again. Well, actually, don't copy this because we're going to change it. But this allowed us to prompt the user and then get the answer and then return it. Now, if you remember when we did our numbers, we had to convert the number into a double. So we did something like this. It said, enter first number, right? So we did that. And then down here, we made this a double and we said, num1 is equal to, and we said double dot parse, and then we did this, right? So this was kind of the way that we converted whatever the user entered into a double. And if you're not sure about this, I did give a full explanation of it earlier in the video. So just go check out that part where we built the calculator. But I want to be able to do this thing similar to the way that I'm doing it up here, because we're going to need to get multiple numbers, right? So I'm going to need to be able to get two numbers, and I'm also going to want the user to be able to enter in like what sign they want to use. So subtraction, addition, multiplication, etc. So we're going to use this prompt method again, but I want to create another one. So I'm going to copy this, and this time it's going to be prompt number. why don't we call it prompt double? And this is going to return a double. And over here, we can get rid of this prompt text. And then I'm just going to say enter a number right there. So this prompt double function, this is going to end up being reused, and we'll be able to use it to get the doubles that we need for our calculator. So this is kind of where we're combining some of these different things together, right? These are what we would call like helper functions. They're just helping us do things that we don't want to have to write out multiple times. So we're going to print out enter a number, and then we're essentially going to use this same line of code here. So I'm just going to copy this up here. So we're going to create a double. Let's just call this num, or maybe that's a reserved word. Why don't we call it my num? I don't know. You can call it whatever you want. But this is going to parse the double out of that input that the user enters, and then why don't we return my num? So now we have two functions. We have the prompt function, which allows us to pass in a prompt text, and then we get the answer back. And then we also have a prompt double function, which tells us to enter a number. We convert that into a double, and then we return it. So these two functions now we can utilize when we're building our more advanced calculator. Okay, so down here in the main, we need to get three pieces of information from the user. We need to get the first number, the second number, and we need to get the operation that they want to perform. Do they want to add? Do they want to subtract, multiply, divide, whatever? So let's go ahead and do that. So I'm going to say, let's create a variable. So let's get the numbers first. So I'll call this num1, and I'm going to set this equal to prompt double. Now, because we put this into its own function, all I have to do to get the number is just call the function, and it's going to return that number back to me, and I can store that inside of num1. And again, we kind of went over this like in a little bit more detail, so if you're still feeling a little bit confused, I would recommend going back to the, I guess, either the function section where we talked about returns, or if you're not sure what's going on here, then we talked about that in the first building a calculator section. So please go back and watch that. You don't want to do this if you're like too confused about it. So we have that first double. Now let's get num2, prompt double, boom, just like that. Now I just want to demonstrate real quick how this would run. So when I run this, again, we're prompting for all this stuff. Now I must have messed up somewhere. And let's see. Oh, okay. So it's because I actually copied this. So this is why I'm getting an error. So just delete that. Okay, so I'm going to run this, and it says enter a number. Okay, so I'm going to enter number 4. And once again, all of this code is going to be what's running. So I enter my second number. I guess these should be doubles, right? So I'll do that. So just from these two lines of code now, because I'm able to reuse all of this, I'm able to get both my numbers. And then the last thing we want to do is get the operation. So this would be addition, subtraction, whatever. So we can just call that OP. And let's set this equal to prompt. So we're going to prompt the user. Now we wrote this function before. We need to pass it a prompt text, and we'll just say enter an operation. And then in here we could say like plus, minus, divide, and multiply. So now we're able to get the first number, the second number, the operation. Let me show you this just so we can make sure it works. So two numbers, and then the operation. This is like wrapping a little bit, but we could put like a plus sign there. Cool. So this is all stuff that we've gone over, right? We've gone over all this code. Obviously we made this new function. That was pretty fun, but this isn't really any new stuff. What I want to do now is show you how we can determine if we should add, subtract, multiply, or divide based on this, right? So we have this piece of information. This will tell us what operation the user wants to perform, but we need to be able to use that in our code, because the code is what needs to make the decision, right? If someone said, I want you to add these numbers, I just use my super smart brain and I do that, right? It's easy. But the computer is dumb, so we need to like program intelligence into it. So let's go ahead and do that. Now, what I want to do is I'm going to create a series of if statements, just like we did in the last one. And the first thing I'm going to do here is I'm going to check to see if the operation is equal to, and this double equals right here will allow us to check if one thing is equal to another. I'm going to check to see if the operation is equal to the plus sign. So if the operation is equal to the plus sign, then down here, I'm just going to print out num1 plus num2. Perfect. So just like that, now we have an if statement. So believe it or not, this program now is smart enough to be able to add two numbers. So if we run it, I can put in two numbers here like 4.5 and 2.3, and then I'll put addition. Now, because this if statement is checking to see that the user entered a plus sign, we'll actually be able to get the answer. So I'll hit the plus sign and then it actually prints out the answer. Now, if we do this, if we try to do this with like, let's do this, and then we try to do subtraction, it's not gonna work, right? Because we're not checking that condition. So let's go ahead and check that. So I can say else if the operation is equal to the minus sign, and then down here, we'll do that same thing. So in this time, instead of adding them, we are going to subtract them. And let's just see now if subtraction works. Always a good idea to just run your code anytime you change it, just so that way you stay on top of it. Because if there's errors, then you want to make sure you get them right away. Okay, so then we were able to subtract them. Looks like that worked pretty well. So let's do the same thing. We'll add in another else if. Now we're checking to see if the operation is equal to the division sign. And if that is indeed the case, then we will print out num1 divided by num2. And I bet you can guess what the next thing we're going to do is. I'll actually just copy this. We are going to check for multiplication. So now we do the little star, whatever that is, and then we'll multiply. So now we should be able to handle each one of these operations. So why don't we just try like multiplication? We'll see if that works. Okay, so we're going to enter a number. Let's do 7.5 and then maybe like 8.0, and then we'll try to multiply them. And so there we go. It was able to multiply those two numbers. Cool. So this is like a really common thing that we do, right? We're checking all of these different conditions, and depending on the condition, we're printing something else out. So this hopefully demonstrates like where these else ifs and everything comes in handy. Now we could add in an else here because there's another situation that we're not accounting for, which is the situation where we have an invalid operator. So if the user just goes crazy and, they try to add 4 and 3, and then they add in like, some crazy text, then we can just tell them it's an invalid operator and we don't have to worry about it anymore. So right here, this demonstrates what I think is a pretty good use case for all of this stuff. Okay, so that is our better calculator, and you can keep playing around with this if you want. That's totally fine. I do want to show you one additional thing that we can do here, and it's going to involve introducing a new topic, which is called switch statements. So a switch statement is actually very similar to an if statement, except that it's only used in very specific circumstances. And those circumstances are where we're checking to see if one thing is equal to a bunch of other things. And believe it or not, this situation is exactly the perfect situation for a switch statement. Now we can do this with if statements. This is totally fine. You're never in the wrong when you're using an if statement. It's just sometimes these switch statements can make our lives a little bit easier. So I'm just gonna demonstrate real quick what they do. You don't have to these aren't like the most commonly used things in the world, so don't worry if it's not super clear, but I just want to show this to you. Now, one thing I want to point out about this situation up here is that in each one of these conditions, right, in each one of these, we call these Boolean expressions, we're checking to see that the operator is equal to something different. In each one of these, the operator shows up. And when you have a situation like that where the same value is getting compared to a number of different values, like we're comparing the operator to a plus, to a minus, to a division, to a multiplication, when you have a situation like that, it's perfect for a switch statement. So let me show you how we can replicate this code as a switch statement. And you'll see it's kind of a little bit more readable, I guess. So the switch statement is going to be structured like this. So we're going to have an open and close parentheses, open and close curly bracket. Now in here, I'm going to put the variable or the value that I want to compare to multiple values. So in this case, this is our operator. So I'm going to put the operator right in there. And now I'm going to say case. And in this case, I'm going to say addition and then a colon. Now the syntax for these switch statements is a little tricky. And if you get it wrong, then it will yell at you. So just be careful. But you're going to say case. And then in this case, we're saying the plus and then this colon. And then down here, you want to indent. and you're going to just put whatever like line of code you want. So in this case, it's just the print, and then you're also going to need to put one more keyword, which is called break. We'll talk about what break does in a second. So we have this case of addition, and basically like the way you could read this switch statement is you could say, okay, we want to take this operator. In the case that the operator is a plus, I want to do this, and then I want to break out of the switch statement. That's all this is saying. So in the case that we have an addition sign as the operator, print this out and then break. And we can do this for each one of these. So let's do this for addition, subtraction, and I messed that up, multiplication. Man, I can't get this. Okay. Addition, subtraction, and then we're going to change this to subtraction as well. Multiplication, we'll change this to multiplication, and division. And then we're going to change this to division. So I'm basically just replicating the same code. And I wonder if I can comment out. Okay, so I'm just going to get rid of this for now. We'll bring it back. And if I run this, you'll see that the code should work exactly the same. So 6.0, 9.8, and let's multiply them. So you can see we were able to get an answer out of that. So the switch statement is just doing the same thing. It's just a little, I guess it's a little bit more concise. Here's the thing about switch statements. Like there's very specific cases where they're useful. This is one of them, but in a lot of cases you can just use an if statement. Like there's certain programming languages, like I don't think Python has a switch statement. I don't know. I think most of the other languages do. I don't know. Maybe Ruby. I don't know that Ruby has one. Anyway, it doesn't really matter, but these are pretty useful. Now, the last thing that we would want to add in here would be, you could say default, and default would just basically be like that else. So here we could say invalid operator. So let's run this, and 4, 5, and then we'll do an invalid operator, and then it's able to do that. It's able to handle that. Okay, so there's, like I said, two ways that we could kind of write this out. Now, the last thing I want to do is talk about this break keyword. And the break keyword is significant because, well, let me just show you. So let's say we remove the break here, and this ends up being a plus again. So this maybe isn't the best case, but I just want to show you or actually no, we would want to do this. So I'm going to remove the break up here. So in this case, we have two of these case statements which are both going to end up being true. Now, most of the time, these aren't going to be like the same character, but in this case, both of these could be true. So if I don't put a break statement right here, if I remove this, and then we do the addition, and what do we got? Okay, I got to put a semicolon. So, okay. Switch case may fail. Okay, so it's actually giving us an error here. So this is like not helping my point at all. But the whole point is that if you put the break keyword here, once this code gets executed, this is telling it to break out of the switch statement. So we'll completely leave the switch statement. If this break keyword isn't here, then it would keep going. It would execute this code, and then it would keep going down. And then here it finds another one that also matches, and then so it would do this again. Now, Dart's too smart for us, right? It knows what we're trying to do here, but that's kind of the idea of the break. All right, so I want to bring back that if statement real quick, just like Command Zing. And these two things, as I said, are like pretty much equivalent. Okay, so that's a little bit about how to build this like more advanced calculator. And if you want, just you can play around with it. You could add in some other stuff like square roots or whatever, just add in additional operators, but that could be kind of fun. Okay. I'm going to get rid of this, and I'm actually going to keep both of these because I think we may end up using them again. Not exactly sure. But now I want to get into what is kind of the next big topic. So we've talked about if statements. We talked about some data structures, getting input from users. One of the last core topics that we need to cover is this idea of looping. And once we start adding loops into our programs, they just become like infinitely more powerful. A loop is a way that we can execute the same code multiple times. So there's a lot of times in computer programming where we want to do something multiple times. And generally this is related to data. So if we have like data, for example, that's in an array, we might want to do something for each element in that array. So we might want to just like repeat the code over and over again. And there's a couple different ways that we can write loops. I'm going to walk you through what I think are some of the most common, and hopefully just like try to get some of this like into your head. So the most basic primitive type of loop is called a while loop. And a while loop, I really just have to demonstrate it. So I'm just gonna write it out here and then we're gonna walk through exactly what it's doing. So this is kind of like the simplest while loop we could write. I'm gonna create an int up here, which is called I, and I'm gonna set it equal to 0. And in here, I'm gonna say I less than 5. And then down here, I'm going to say print I, and just stick with me. I know some of this is confusing. And then down here, we're gonna say I++. So here is my while loop. It's pretty much the most basic while loop that we can write. And I'm gonna go ahead and run it, and I wanna show you what happens. And then we'll talk about each of these different parts. So we'll run this, and you can see that the numbers between 0 and 4 got printed out over here onto the terminal, or onto the console. So what exactly is happening here? A while loop is a programming structure that allows us to repeat code as long as a particular condition is true. So the while loop has multiple parts. Obviously, we have the name. Now, this is very similar to if statements. So inside of these parentheses, we have a condition. We also call this the loop guard. As long as this condition is true, we are going to execute the code inside of the while loop. And every time we go through and execute the code that's in here, we're going to go and recheck the condition. So let me walk you through real quick, just step by step, how the computer is executing this while loop, and we can get a feel for what's going on. So up here, I'm creating an integer I, and this is a really common thing to do. We call I, stands for index, basically like a counter. And as long as as long as this variable I has a value that's less than 5, now remember, this is either gonna be true or it's gonna be false. It's a Boolean expression. So it can get reduced down to a true or a false value. So as long as this is true, right, then we execute this code. So the computer goes through and it says, okay, we have this integer I, it has a value of 0. Now we have a while loop. So before I execute any of the code inside this while loop, I'm gonna check this condition. If this condition, this Boolean expression, is true, then I'm going to execute all of this code. So the first time that we go through this loop, the computer checks the condition. I, at this point, has a value of 0, which is indeed less than 5. So we're going to come down here and we're going to print out 0, right? We're going to print out that value. That's what's over here. And then we're going to increment it. Remember we talked about this increment operator? This is basically the same as saying I is equal to I plus 1. So we can just do plus plus. And okay, so the computer goes down, it prints out I, which is this 0, and then it increments I. So it adds 1 to the value of I. Now the computer is going to come back up to this loop guard. It's going to come back up to this condition, and it's going to check it again. So in this case, I has a value of 1, and we can check to see, okay, is 1 less than 5? It is. So then we're going to execute the code again. So we go down to this print I. In this case, we're printing this 1 over here, and then we have I++, so we increment it. Computer's going right back up to the top of that loop. So now I has a value of 2 because we've incremented it. 2 is less than 5. So then we go through again, we print out 2. Now you kind of get the idea. We just keep doing this. We keep executing the code and then rechecking that condition. Eventually, once we've printed out 4, so in this case, we print out I has a value of 4. Now we increment I now has a value of 5. We come back up to check the condition. 5 is not less than 5. 5 is equal to 5. So it's false, which means we break out of the loop. So it's only as long as this condition is true that we're going to keep executing the code inside. And with these while loops, it's very important that whatever's up here in your condition is hopefully changing or potentially changing each time through the loop. Otherwise, you're going to get into what's called an infinite loop. Now, let me demonstrate an infinite loop for you guys. I'm just going to, and I hope this doesn't break my REPL, I'm going to get rid of that I++, and I'm going to run this code. Now, check this out. It's just going to keep printing out all of these zeros. And I actually just stopped it. But you'll see here that we just, and actually I can scroll down. You can't really see it, but it's all just zeros. What's happening here is we check the condition. I has a value of 0, which is less than 5. We print it out, and then the computer comes right back up here and checks that again. We didn't modify the value of I, so I still has a value of 0. So this is still true. And in fact, we're never modifying the value of I, so this is going to infinitely loop. And that's what we call an infinite loop. So a rite of passage for all new programmers is to just, accidentally write an infinite loop. I remember when I was in college one time, I was doing programming in like this really low level language called C, and I was running all the code on this server that we had at the university, and my teacher was like, we were basically like learning how to spawn processes, which is basically like spawn other programs that like take up memory and everything. And he was always like, okay, don't write an infinite loop while you're spawning these processes, because then you're going to crash the server. And then of course I ended up doing that, crashed the server. So I definitely have my fair share of like trepidation with these infinite loops, but I digress. So that's a little bit about a while loop. And it's really, really important that you're always, whatever's in this condition, it should become false at some point. Otherwise, the loop will go on forever. Okay, so these while loops are good. Now, this is a very simple example. I like this example. It's kind of the classic while loop example. But now I want to show you like some things that we can do with this. So what I want to do is build a little guessing game. This is going to be the first. Obviously, we've built calculators, which is fun. But the guessing game is like, I really like this project because it's kind of like more advanced, and I think it's more of like a program than just like some calculator. So the idea of the guessing game is we're going to have like a secret word, and the user is just going to try to guess what the word is, right? Almost like they're trying to guess a password or something. And then if they get the word correct, then we'll say like you won or whatever. So we're going to write out this program. I'm going to write it, and I'm going to be walking through it, and hopefully showing you how it works. So to write this program, we're going to need a couple of pieces of information. The first thing we need is like the actual answer to the guessing game. So maybe the answer to the guessing game can be like Michael Scott. If you watch The Office, or if you've seen my other programming videos, I love The Office. So the answer is Michael Scott, right? That's what we're trying to guess. And then we're also going to have a variable here, which is called guess. And this is just going to be an empty string to start off with. So an empty string is when there's nothing in there. And you can actually see here, this is like force of habit. I'm using these single quotation marks. With these strings, you can use either double quotation marks or you can use single quotation marks. I feel like I'm more used to using the single ones. It doesn't really matter. They're both the same exact thing. But I guess I can use doubles just because that's what we've been doing. So this is what we call an empty string. It's a string that has length 0 and it has no characters in it. And these empty strings are pretty useful. So we have our answer, which is what the user is going to try to guess. And then we have the guess. Now this is going to store whatever the user is guessing. And this will start to come together in a second that you'll see. But this is what we're going to use to keep track of like the guesses that the user has given us. Now the guessing game is unique because the user should be able to guess multiple times. So we don't want to just give them one chance to guess. We want to be able to give them multiple chances to guess. And whenever we want to do that, like basically we want to let them guess the answer until they get it right. Perfect situation for a while loop. So I'm going to go ahead and write out this while loop. Now, whenever you're writing the while loop, you can almost just like read it like you would a paragraph. So I want to say, like, let's just think at a high level, like what we want to do. While the user hasn't guessed the answer, I want to keep prompting them to guess, and I want to keep checking their answer. So that's really what we want to do. And so we could basically say while the guess, so whatever the user's guessed, is not equal to the answer, then down here, I basically want to prompt the user to guess, and then I want to check to see if they got it right. So we have a way to prompt the user for something with this prompt function. You can see this is coming in handy even more for us, right? So down here I can say guess is equal to, and we're going to call that prompt function, and I'll say enter a guess. So what's happening here is we're saying as long as the user hasn't guessed what the answer is, as long as the value that's stored inside of the guess variable isn't equal to the value that's stored inside of the answer variable, then we want to say that the guess is equal to like whatever we prompt the user for. And then down here, and we can walk through this some more, don't worry, I'll keep going over it, but we can just say you won. So if they get down here, that means that they've broken out of this loop and they've won the game. So let's run this code and we'll see what happens. Okay, so it's saying, and actually it says the prompt is here. So let's get rid of that. We don't need this anymore. Let's just put the prompt text. So if you remember, we just kind of, I think I just added that to demonstrate something. So we're gonna run this and it says enter a guess. So what I'm gonna do now is I'll enter in like what I think the answer is, right? So I could say, you know, maybe it's hello, right? And I'll hit enter. Now you'll notice that it asked me for a guess again. So what's happening here is initially the guess doesn't have a value. So this guess is an empty string and it's not by default equal to the answer. So when Dart executes this, it's going to go down, it's going to create these two variables, and then it'll say, okay, while the guess is not equal to the answer, it's going to check this condition. And in this case, the guess is an empty string, which is not equal to the answer. So then we get prompted to enter a guess. And that's exactly what's happening here. So I run the program, we check the condition, it's true, you know, the guess is not equal to the answer. And then down here we say, okay, the new guess is equal to whatever the user enters in when we prompt them. So down here, I could type in hello. Now what's gonna happen is I type in hello. So the guess variable now has a value of hello. We go back up to the top of the if statement. We check the condition, or the if statement, the while loop. We check the condition again. So guess now has a value of hello, which is not equal to answer. So this condition is true, which means we need to go down and prompt again, which is why we're getting this. So I could, you know, type in whatever here, like I'm just randomly guessing, none of it's equal to Michael Scott. When I finally do type out the sacred name of Scott himself, you see that it says you won. So eventually we get prompted, we enter in Michael Scott. So now the guess has a value of Michael Scott. And then we come back up, we check to see is guess, which is Michael Scott, equal to the answer, which is Michael Scott. It is. So this now becomes false, because the guess is equal to the answer, and then we come down here and we print out you won. Now this logic here, this like not equal to logic, is really hard to wrap your head around as a beginner. That's one of the reasons why I wanted to show you this example, just so you can get some experience with it. So this whole thing is true when they're not equal, but when they are equal, this whole thing becomes false, which is a little like unintuitive to think about, but that's just kind of the way that it goes. Okay, so this is looking pretty good. Now, this is kind of like the basics of these while loops. Another thing that we could do as well is we could create like a guess count. So this is just one little extra thing you could add in. And the guess count is going to be equal to 0. So initially the guess count is equal to 0, and this will just keep track of how many times they've guessed. And so then we're going to prompt them, and then every time we prompt them, we will just increment the guess count. So guess count plus plus. And then down here we could say you won in, and let me interpolate this, guess count guesses. So now check this out. If I run this and I enter a guess, like let's just enter in a bunch of, you know, whatever, 3, and then I finally get it right. Now it says you won in 4 guesses. So this is just like another little add-on we can do, but you can see here, like what I'm doing with this program is I'm combining all of these things that we've learned so far. So we're using this prompt function. We're using all these different data types. We're using this while loop. We're using these Boolean expressions, these comparisons. We're using string interpolation. We're using this increment stuff, right? So all of this is getting combined together, and that's what coding's all about. And that's really why, as a beginner, it can be sometimes hard to break into this skill and learn these languages, because unlike a lot of other things where you learn this thing and you learn that thing, with coding, it all builds on each other. So in order for me to build this guessing game, I had to pull on all of the concepts that we've covered so far in this course, except for, I guess, if statements, but even this is kind of a conditional anyway. So I had to pull on all of those different concepts in order to build this. So if you are just starting out and you're getting a little bit overwhelmed or intimidated by something like this, it's completely normal. I mean, I remember starting coding and like, I wouldn't have been able to write this at all. Like this would have confused me so much. So if you're at least getting it a little bit, that's good. The way you get better at coding is just by practicing. So my advice is, if you're a little shaky with this, just try to rewrite it a couple times, just practice with it, and then you should get a little bit better. Okay, the next type of loop, so we're still on this looping concept. Believe it or not, loops are a massive topic. This type of loop is a while loop. This is the simplest, most basic type of loop. And all the other loops that we're going to talk about, because we're going to talk about another type of loop, all of them are just like specialized versions of the while loop that allow things to go, I guess, like a little bit smoother. So I'm going to show you two other types of loops. We're going to look at a traditional for loop, and then we're going to look at, I guess, what would be called like a for in loop. So you'll get exposure to two other types of loops as well. All right, so we can get rid of some of this stuff because we're done with the game. Now I want to bring back a program that I had before. So I had int I is equal to 0, and then we said while I is less than 5. And then down here we printed out I, and then we said I++. So you guys remember this program that we wrote like, I don't know, 10 minutes ago? So this allowed us to print out everything from 0 to 4. This, believe it or not, where we have this variable I, and every time we go through the loop, we increment it, this is super common in computer programming. And we're going to take a look at like why it's super common in just a second, but I just wanted to kind of make the parallel here. So what we're doing here is we have this I. Every time we go through the loop, we increment it. And the reason that we call this I is because it stands for index, and it's basically an index of which execution of the loop that we're on. I don't know, there's probably a better way to say that. But so for example, 0, this would be like and again, in computer programming, we always start from 0. So this would be like, the 0th time that we go through. This would be like the second time, the third time, whatever. So it's just keeping track of like how many times we've gone through the loop. And this is really useful if we want to loop through an array, or a list. So remember we had this list data structure, and let me just do this. So why don't we have a list of strings, and I'm just gonna call this friends. So this is like maybe this is like a friends list for like Facebook. So we can have like Stanley, we can have Pam, and maybe we have Karen. Okay, so we got 3 friends that are on our friends list. And if you remember with these lists, we could say something like this. So I could do this, and I could say friends at index position 0. So I can use this special square bracket syntax, and I can refer to a friend at a particular index. So if I ran this program now, we should print out Stanley, because Stanley is at index position 0 in this array. And if you remember, we have our index positions. So Stanley would be 1, Pam would be 2, and then Karen would be 3. Or sorry, no, totally wrong. Stanley's 0, Pam's 1, Karen is 2. See how confusing this is? I've been programming for a decade, and I still get weirded out about these starting at 0 things. So we can refer to like Stanley like that, but imagine if we wanted to print out each one of these friends individually. Well, believe it or not, this I value is going to allow us to do that. So let me show you real quick. Instead of just printing out I, I'm going to print out friends at index position I. And let's see what happens. So now if I run this, and actually this should be 3 because we have 3 friends. That's why we got an error. So if I run this, you'll see that it prints out Stanley, Pam, and then Karen all in a row like that. So we have 3 friends that are in our friends list. And we're saying as long as I is less than 3, we're going to print out the friend at index position I. So the first time we go through this loop, I has a value of 0, and we print out friends at index position 0, which is Stanley. The second time through, I has a value of 1, so we print out friends at index position 1, which is Pam, and then finally we print out Karen. Now we can make this a little bit easier. So remember we have that length property, so we could say friends.length, and in this case this should give us 3 because we have 3 friends. So instead of saying I is less than 3, we could say I is less than friends.length. And this is like a really, really common thing to do in computer programming, where as long as I is less than the number of friends in the list, we're going to print out each friend individually. So we kind of get that here. This is what we call like looping over an array. And we can use these loops we can use these loops in order to like do something for each one of these elements. So for example, I could say friends.i.to uppercase is another one we looked at. And now it'll like capitalize all of these friends or whatever. It'll do something like with each element in the list. Super, super common. And so whenever we want to do something like this, where we want to loop over these friends, we can do this in a while loop. But this is actually such a common thing that we want to do that there's a special kind of loop that'll be able to do this for us. And specifically, I'm talking about being able to keep track of this index variable, which we can then use to look at all the friends. I know this is getting a little confusing. This is one of those more advanced topics. So if you're like really confused, that's okay. Just keep watching. I'm going to try to explain it as best as possible. But really, this is just about like practice. Okay, so we have this situation where we have this index variable, and every time we go through the loop, we're incrementing it. And we saw one of the ways that we can use that, right, to like print out all these friends. If you have a situation like this where you want to do it, there's a better, more concise way that we can using something called a for loop. So I'm going to create a for loop. It looks exactly like a while loop in its structure, except that inside of these parentheses, we're going to put three things. So I want to first off point out three things that are going on in this while loop. First thing is we're creating a variable called I, and we're giving it an initial value of 0. So this is the first thing that we're doing here in this little while loop structure. So I'm actually going to take this, and we call this the initialization of the counter variable, or initialization of the index. I'm going to put that right here. So I'm just going to paste that right up here. Then I'm going to put a semicolon and a space. So this is like the first section that's going to go inside of these parentheses. The next thing that I'm going to do, and the next thing I want to point out over here, is the condition of the loop. So this loop has a condition, which we're going to check every time we go through it. Basically, like, have we gone through all the friends yet? So I'm going to take this and I'm going to put this right up here next to it. I'm going to put a semicolon and a space. And then finally, you'll notice that we have this I++ down here. So this is what increments the counter every time we go through the loop. Increments the index is what I mean to say. So I'm going to take this and I'm going to put this up here, and I'm not going to put a semicolon after it. So we have three things that are going in this parentheses. We're initializing the variable I to be 0. We have our loop guard, or our loop condition. And then over here, we're incrementing I. So this structure now, if we put this in a for loop, is going to allow us to do exactly what we did down here, just without all of this messy boilerplate. So now check this out, and I can get rid of the while loop now. If I run this, it should do the same exact thing. So this for loop and this while loop are literally identical. And the for loop just makes it more convenient for us to do this. So once again, the most confusing part about this is generally these things up here. So we're initializing the variable, and then we have our loop guard, our condition. And then over here, this is a line of code that's going to be executed after each iteration of the loop. So generally, this is just going to be I++. You don't have to change it. It's always going to be the same thing. Okay, so this is pretty cool. Now, these for loops are useful, but there's actually an easier way that we can do this as well. So like, this is what we call like a traditional for loop. This isn't all the old programming languages. Most of the more modern programming languages have this included, but generally it's not used as much. Generally, especially if we're doing something with these arrays, we have even more specific ways of doing it, but you need to be exposed to this because this is like very common code, especially like in particular types of code bases. So here we're like printing out all of these friends, right? Essentially, we're doing something for each of the elements inside of this array. Very common. You can do it with the while loop. You can do it with the for loop. But there's an even better way to do it using what's called a for in loop. So we can replicate this same code by saying for, and then in here, we're going to say string friend in friends. And then down here, I could print out essentially something similar to this, except I'm just going to print out, and actually, I probably shouldn't have put that there. I'm just going to print out friend. So let's run this code, and you'll see here that this for loop, we call this a for in loop, This is the execution over here. So we printed out Stanley, Pam, and Karen, each one individually. And then down here, we did this other for loop where we were like uppercasing them, whatever. But that's a little different. But you can see they're basically doing the same thing. And we could say like to uppercase here on this friend, and then that would kind of replicate it over there. So this for in loop is used primarily when we're looping over a data structure like an array. And I think we can only use it with arrays actually, or a list. Like same thing, right? Array and list. So whenever you want to loop over and do something for each friend, like print out each friend, you want to use the for in loop. The for loop though, which is a little bit more flexible, it gives you access to the counter, right? It gives you access to this I. In certain specific situations, you're going to want that I, and so that's why we still keep this guy around. But most of the time, we're doing stuff with arrays, so you can just use the for in. But like I said, you need to be exposed to both of these. Cool. All right, so this is the basics of for loops. Okay, we've looked at how we can loop over an array. We looked at how we can do this with counters. Now I want to just show you another little quick example. And this is going to go back to those triangles. So you remember we were drawing those triangles, and I'm actually going to get rid of these. So this is like going back to the beginning, and we had like our triangle here. So it looked like this, and then let's just do, let me see here. Okay, so we'll do this, and then wait, this needs, man, I always suck at drawing these triangles. Okay, so here's our little triangle, right? This is good. We can print this out. It works. I'm going to show you, because one of the things that we did with functions, right, is that we created a function that I think it was void. So this just means it doesn't return anything. So we created a function which was called draw triangle. And this just did this, right? So then down here, we could say, draw triangle. We do this a million times, right? And one of the things we were trying to do was draw, like, see if we could draw 5 triangles. So here this works, right? We can draw 5 triangles, but you'll notice that we have to call it 5 times. That's a little inconvenient, right? I wonder if there's a way that we could tell the draw triangle function how many triangles we want it to draw. And of course there is, and we're going to use a for loop to do that. So the draw triangle function, we're going to change it around a little bit, and it's going to take in an integer, so a whole number, non-decimal number, which is going to be called num triangles. And we're going to use this. So now if we call draw triangles, we have to pass it a number, right? I could pass it a 5. And what we'll do is we'll use the number of triangles to determine how many triangles we should draw. And we can use a for loop for that. So I'm going to create this for loop. And once again, I want to walk you through what's going on in these parentheses. So the first thing we're going to do is we're going to initialize an integer called I, which has a value of 0. And 90% of the time, this is what you're going to do. So just as long as you just memorize that, it's fine. And then we need a condition. So I can say while I is less than the number of triangles that I want to draw. And then finally, this is going to be a little line of code that gets executed after each iteration of the loop. So once again, we're initializing our counter, our index. As long as that's less than the number of triangles, then we're going to keep incrementing it, and we're going to do the code in here. So if I put this print stuff in here, now I say draw triangles 5, this is actually going to draw 5 triangles, because it's going to say, okay, the number of triangles that I want to draw is 5, right? We're passing that in as an argument. As long as this index variable is less than 5, is less than the number of triangles that I want to draw, I'm going to draw a triangle. And so, you know, we could put like 10 in here. It'll just do whatever we want it to do. So that's now like this working function, and this hopefully gives you an idea of like what we could use this like traditional for loop for. Okay, anytime we need to like do something a certain number of times, like unless there's like an array involved or a list like we saw, then you can use this. Okay, so that is drawing multiple triangles. Now there's one more big topic that we need to get to in this tutorial, and then we're pretty much done with all the like core concepts. But before we get into that, I want to show you one more thing, which is called comments. Now we've talked a little bit about comments, and we can get rid of this. This can just go away. We talked a little bit about comments, I think, throughout this video, but I really want to just like dedicate some actual time to it. So a comment is basically a tool that us as programmers can use to notate our code and to provide clarity for the different code that's in our program, or just to kind of like what we do is called commenting things out. So there's two ways that we can do comments. There's what's called a single line comment, and you'll see here my text editor is changing this. So there's these two characters here, 2 forward slashes, that indicates a comment. So anything that comes after these 2 forward slashes on this single line, that's gonna be a comment. And the comment is just, like I said, it's something that the computer is just going to ignore. So this is for humans. This is not for the computer. So I could put, for example, if I put a print statement here and I said hello, and well, whatever, if I can type correctly. We said hello, and then over here you'll see it says hello. I could do what's called, we call this commenting it out. So I'll put these two, and generally you'd want to put a space here, but I don't think you need to. So you put these 2 forward slashes, and now it's basically not part of the source code anymore. So the computer is just going to ignore it. It won't execute it. So that's a single line comments. Now, if we go to the next line, you can see that it's back to non-comments. You can make a multi-line comment by making a forward slash and a star. And then you can close it off, because you'll notice that like everything now below this is a comment. So you can close it off with another star and then another forward slash. So now everything that's inside of here is a comment, but everything that's outside of it is not. And these double line comments, single line comments, you can use them for anything. One of the best uses for these is to comment out code. So sometimes like in your code, you might have, this is going to be a very simple example, but okay, let's say that we have 3 lines of code and one of them is wrong, right? So we're saying print instead of print. I run this, it tells me what's wrong, right? Okay, so I kind of know what the problem is. Let's say that I wanted to like try to run this without this line, I could just comment it out. Or I guess I could fix it too, but I'm kind of I'm not really explaining this very well. But if there's code that's in your program and you just don't want it to run on that execution of the program, you just comment it out. And that's pretty simple. Now, there's a lot of different philosophies around writing comments. One thing I will say, though, as a beginner, it can be really useful to use comments to explain each line of code that you write. So, for example, up in this prompt function, like when you're first learning how to code, it's really important that you understand what each line of code is doing. So a lot of times what people will do as beginners is they'll come in and they'll comment each line. So they'll describe what each line is doing with a comment. So they can say here, we're printing the prompt text onto the console, right? And then down here, they could say we're getting input from the user and storing it in a string called answer. And the reason that this wrapped around is just because my text editor is wrapping. It's actually all in one line. So, and then we can come down here and, return the answer and stop execution of the function, whatever. So I'm just going through and commenting all of my code, and then especially when I'm learning how to code, what it does is it forces me to understand each line. Now, this isn't something that you want to do if you're working at a job. People will be really mad at you. A lot of people get really upset when there's comments in the code if they're inappropriate comment. Well, inappropriate, I just mean they're not productive or anything. But as a beginner, it's such a good way to hone your skills. So I definitely recommend doing that. Okay, so that's a little bit about comments, and like I said, comments can be really useful for a number of reasons. But now I want to get into our last big topic, and this is one of the biggest topics of computer programming. But actually, before we do this, I just want to say that up until this point, we have covered just so much stuff. So this is really the last piece that's going to kind of hopefully bring everything together. And that's something called object orientation, or object-oriented programming. You also hear people refer to it as OOP. Object-oriented programming is a way of writing your code and a way of structuring our code so that it resembles objects that are in the real world. And this is what's kind of a revolutionary idea when people first started coming out with it. This idea of object-oriented programming, it's so cool. And it allows us to write code and programs that are like better able to model things that are out there in the real world. Okay, so this is traditionally like I think kind of confusing for people, but I'm going to try to break it down like the best way I can. So in what we talked about so far is we have all these different data types, right? So I have like a string, which might be my name, like Mike. We have a double, GPA, whatever. Like maybe your GPA is 3.5. We also have Booleans, right? So is, organ donor, whatever, right? This could be true or false. So we have these three main types of data: plain text, numbers, doubles or ints, and then Booleans. These three types of data can basically represent just about anything that we would want, right? You could represent like any sort of number, any sort of name or plain text or label, and then any sort of true or false value. But the problem is that not everything in the real world can be described using strings, numbers, or Booleans alone. A good example of this is something like a book. So a book can't be represented just in a string or just in a number or just in a Boolean, because books have different properties and things about them, right? So a book might have a title, a book might have a number of pages, a book might have an author, a book might also, like if we're writing a program, it might also have a status, like has it been read or not, or what percent completion do we have, right? So there's certain things in the real world that we might want to represent inside of our code that we just really can't do with any one of these data types, right? It's going to take a combination of these different data types in order for us to be able to kind of represent a book. And when we want to just represent a name or a number, like we have data types for that. So we have the string data type, we have the double data type, we have the Boolean data type. We don't, however, have a book data type. So there's no, in Dart, like the developers of Dart did not build into this language a book data type. That is not something that's given to us by default. What they did, though, is they made this language object-oriented. And when we have object-oriented languages, something like Dart, what that means is that we can create our own custom complex data types. So even though there's not a book data type built into Dart, because it's object-oriented, I can actually create my own book data type. And that book data type will basically be made up of strings and doubles and Booleans. So we'll have this more complex, more abstract data type, which contains like strings and numbers and Booleans and all those different things. So that's really what object-oriented programming is. It's a programming paradigm that allows us to create our own complex data types. That's basically it. So let me go ahead and show you how we might do this. Now, I want to be able to represent a book in my program. So let's say I'm writing, maybe I'm working for, Amazon, I'm working on Kindle product. I want to be able to like store books. So there's a couple of different things, a couple of different attributes that we might want to have in a book. And really what we want to do here is we want to create our own book data type. And that way we can use that book data type in our program for all sorts of logic. So I'm going to show you how to set this up really quick, and we'll just kind of go through and explain. So anytime we want to create our own data type in Dart, we need to create something called a class. And a class is essentially a blueprint for this new data type. So when we define a class, we're basically telling Dart that this is what our new data type looks like. So it's a blueprint, it's a specification for this new data type. So to create a class, there's this keyword we can use called class, and I'm going to call this book. Now, generally you want to name these with capital letters. So most of the variables pretty much all the variables we've been writing, like, my var, like whatever, it starts with these sort of lowercase letters. Classes are always going to start with uppercase. So you're going to say class book like that. And now what we want to do is inside of this book, we want to specify what are the different things that make up a book, because this is our new data type. So we need to tell Dart exactly what a book is. What are the different properties that a book has? And we can define those properties using the data types that we already know. So a book, for example, might have a title, and a book might also have an author. A book may also have a number of pages. Why don't we call this num pages? I'm going to type that wrong. Okay, so this is going to be an integer. So what I'm doing here is I'm telling Dart I want to create my own custom data type. The data types that you've given me aren't enough. So I want to create my own data type, but this is going to be a complex data type. This data type is going to have different properties or different attributes in it. So this book data type is going to have a title. This book data type is going to have an author and a number of pages, and we're defining that here. Now, this book class is only a specification. So this is just us defining what this data type looks like. Now, if we want to use this in our program, we need to create something called an object. So the class is the specification, it's the blueprint. An object is an actual book itself that we have in our program. So once again, this is like a specification. This is us registering this data type with Dart. This is us telling Dart, hey, this is the data type I want to use. And then we can create different books in our program, which we call objects. Okay, so I'm going to show you how to create an object. What you're going to do is you're going to say book. And why don't we make this like a Harry Potter book? This is the example I always use. And over here, you're going to say book and then an open and closed parentheses. So this right here, this is the syntax that we're going to use in order to create what's called a book object. In other words, this is an instance of the book class. Basically, this is like a book itself. So the class defines that a book should have a title, an author, and a number of pages. Down here, we're creating an actual book, which is going to have its own title, its own author, and its own number of pages. And let me show you how to do that. So we've created this Harry Potter book. And then down here, I'm going to say, and actually, let's just call this HP because I don't feel like typing that out. So HP, and what I can do now is I can specify what the title, what the author, and what the number of pages are for this. So I can say HP.title is equal to, you know, maybe like Sorcerer's Stone. And then I can say HP.author is equal to J.K. Rowling. And then I don't know how many pages it has, but we could say num pages, maybe it's like 300, I don't know. Oh, whoops. HP.numPages is equal to 300. So this is a special syntax that I'm using right here, which is basically allowing me to specify what the title, the author, and the number of pages are. So you can say HP, and then you can use this little dot. This is actually what we call the dereference operator. And you don't really need to worry about what that means, but HP, and then you say dot, and then you can refer to which one of the properties or the attributes, basically which one of these things we want to work with. So I can say HP.title is equal to Sorcerer's Stone, HP.author, Rowling, etc. I can basically set each one of these. And what's cool about that is then I can come down here, and if I want to refer to, for example, the title of this book, I could just print out like HP.title, and now it should tell me the title of that. So, and let me see here. I definitely messed this up. Oh no, okay, so I have, it's pages, it's page here, not pages, okay. I'm an idiot. Anyway, this is a long tutorial. So you can see down here that I type out HP.title and then it prints out the title. I could do the same thing for author or for number of pages, whatever, it'll do all of that. So this book data type, right, this book class, we're able to store different properties on it. And what this allows us to do is model real world objects a lot easier. So this is now like one container that has all the different properties that we might be interested in for a book automatically loaded up into it. And this is just really easy because now we can just say like HP.title or HP.author, and we can refer to those really easily. So this is why like these classes and objects, it's just a better way to organize our code. There's nothing magic going on here. It's just like, this is a better way for us to organize things. Now, once again, I want to make the distinction between the class and the object. And I know some of this syntax is funky. We're actually gonna talk about this, but like the class is the specification. This is like the blueprint that we're giving to Dart that tells it what the book looks like. We can create like actual instances of that book that have actual titles, actual authors, and actual number of pages, which are called objects. And it's these objects that we can work with in our program. So the class, it's not it's not real. It's not something that we can pass into a function or print out or anything like that. It's just a specification. The object is the actual thing. It's the actual book that we're working with that has an actual title, an actual author, and an actual number of pages. Okay. So object orientation, it can be a little confusing, but hopefully that makes sense. I found that's kind of a good way to explain it. There's more to do though. We are far from done with object orientation. First off, let's start with this. Look at this. So right now I'm creating my Harry Potter book, and it takes me 4 lines of code to create this Harry Potter book. Let's say that I wanted to create another object. So we can create another book, and why don't we always do like Lord of the Rings. So that'll just be Lord of the Rings, and this will be the book. So I could say LOTR. Now I have to set the title of this, right? So this is Lord of the Rings. And then, okay, we'll do the author. So what is this? Tolkien. And then finally, you can see this is getting a little tedious, right? This is not something that I want to be doing every time I create one of these objects. I don't know, maybe this is 500 pages. So you can see here that when we create this book, and then, oh, and this should be a number. Yeah, see, I'm already messing this up. This is why it's not a good idea to do it this way. So in order for me to create one of these books, it takes me 4 lines of code, and I have to individually set like the title, the author, and the number of pages. This doesn't scale very well. And this is a problem that can be solved using something called a constructor. So I'm going to walk you through what constructors do. Now, the first thing that we want to do is we're going to come into our class here, and you're just going to say book, and then you're going to make an open and closed parentheses, and then an open and closed curly bracket. So this is what we call a constructor function, okay? The constructor function is a function which we can use to initialize each one of our objects with data. So the constructor function will basically do this, and it'll do this for us whenever we create an object. Now let me show you what happens here. So I'm just gonna say print, and we're just going to say in constructor. Okay, so I'm going to print in constructor, and this is like right inside of this constructor function. Now, if I run my code, I want you to see what happens. So you'll see here that it says in constructor twice. And the first time that we do that is when we run this line of code right here. The second time is when we run this line of code. So every time we create one of these books, which is basically done using this syntax, we are calling this constructor. Now this constructor is just like any other method or any other function. So I could have this pass in like a string name, and then down here I could say in constructor, and then down here we'll put the name. So I could pass in a name. So here we could say like this is Harry Potter, and then down here this is Lord of the Rings. Now check this out. When I run my code, you'll see here it says in constructor Harry Potter, in constructor Lord of the Rings. So I can use this just like any other function. I can pass arguments into it, and then I can use those arguments over here. And so because this is just like a normal function, we're going to use it the way that it's intended to be used, which is to do what's called initializing these variables. There's going to be some weird syntax coming up. I need you to stick with me. I'm going to explain all of it. But I'm going to be moving some stuff around. So actually, first things first, why don't we do this? So I'm going to show you how we can make it so that we can pass in the title of the book into this constructor. So inside of this book, inside of this constructor function, I'm going to specify that it takes a string which is called a title. And I'm naming this intentionally with this little a. You'll see why in a second. So down here in the book, I'm going to say this.title is equal to a title. So this is our line of code. And now, instead of using this line of code, I'm just going to pass in the title that I want the book to have in the constructor, and then I'm going to get rid of this. So we'll do the same for Lord of the Rings. And then we'll get rid of this. So now, instead of me explicitly saying hp.title is equal to Sorcerer's Stone, I'm now passing this Sorcerer's Stone value into this constructor function. It's going to get stored in this aTitle variable, and then I'm saying this.title is equal to aTitle. So before we do anything, let me just show you that this is working. So let's print out hp.title down here. So let's do that. and you'll see that it has that same title. So we achieved the same end goal, which is giving Harry Potter this title. It's just that we did it through this process. Now, the one thing that's probably not making sense here is this thing. So it says this.title. The this keyword is a very special keyword that we can use inside of this class. So anytime you're in a class, you can use the this keyword, and it will refer to the title of the object that's getting created. I know that's a little wishy-washy. We're gonna do some more stuff with this. So if that doesn't fully make sense yet, it's okay. But essentially what I'm saying here is I'm creating this Harry Potter book, okay? I create it by calling this constructor function. Now you can specify your own constructor function. If you don't have one in there, then it just like will create the object for you, okay? So you don't need to have that there, but you can. So I'm creating this object, and when I do, it's gonna call this constructor function, and I can pass in a value for something. Now in this case, the constructor is gonna take a title as its first argument. So Sorcerer's Stone now is going to be stored inside of this aTitle parameter. And then over here, when I say this.title, it's basically the same as me saying HP.title is equal to whatever over here. So this line of code and this line of code are basically equivalent. The this keyword refers to the object that's getting created. So when we call this function for the Harry Potter object, this.title refers to the title of the Harry Potter object. When we call the constructor with the Lord of the Rings object, this.title refers to the title of the Lord of the Rings object. So it just depends on when we're calling this, basically. Again, if this doesn't fully make sense, that's okay. Okay, object-oriented programming is this is intense. I mean, when I was in college, I had 3 or 4 classes just on this. So it's definitely a little crazy, but hopefully you guys are getting the point at least a little bit. So we're doing this with the title. Now we can do the same thing with the author. So this is going to be a string author, and then also for the num pages. And I'm going to call this actually a author and a num pages. We can talk about why in a second. So then I'm going to do the same thing. I'm going to say this.author. So the author of the object that's getting created is equal to the author that we passed in. So over here, we're going to pass in J.K. Rowling as the second argument, and then Tolkien as the second argument as well. And then we can get rid of these. Cool. And then we'll do the same thing for the num pages. So this one was 500, and then this one was 300. Beautiful. All right. And then last thing is we need to say this.num pages is equal to a num pages. So now we've seriously reduced the amount of code that we need to write to create these objects. And now we can run this, and you can see that it's still working. So we're still getting Sorcerer's Stone, and let's try author and num pages as well. Okay. Looks like author's working and num pages. Cool. So these are the constructor functions. They just make it really easy to create these objects. Now, I want to talk about the naming up here. So I called these parameters a title, a author, and a number of pages. And once again, I want to make the point that this is just like a normal function. So when I call this constructor function, I pass in the Sorcerer's Stone, which gets stored in a title, J.K. Rowling, which is stored in a author, and 300, which is stored in a number of pages. So most of the time, you're not going to use these A's. You're just going to call them author, num pages, and title. I'm just putting these A's in here because for beginners, a lot of times it's not clear the difference between this title and the title that's over here. So hopefully you guys get that. But you're not going to see that in production code bases. You're going to see just using title or whatever. So let's keep this for now because we're just starting out, so we want to make sure that we don't confuse ourselves. But otherwise, that is the constructor function. So hopefully that makes sense. And really, this is one of the core parts of object-oriented programming. And here we're really creating these classes. Okay. Now, the last thing I want to do, I think this is the last thing. Yeah, last thing I want to do is talk about class functions. So this should hopefully shine a little bit more light on kind of what we're doing here. But this will be the last topic that we'll cover. There's a lot more that we could get into with object-oriented programming, but I think for a beginner's course, this is probably just the right amount. So we'll leave it at that after this. Okay, so I'm going to get rid of the book class. I'm going to get rid of all of this. I want to start over. We're going to make a new class. This one's going to be called student. So once again, we're specifying what this like complex data type is. And the student is going to have two attributes. So the student will have a name, and then they'll have a double, which is their GPA. So I don't know how it's done all over the world, but in the States, we have this concept of a GPA. It's like a grade point average. So it's between 0 and 4. If you have like 4, you have straight A's. If you have 0, you're not doing too good. So the student has a name and a GPA. And then why don't we create a constructor function? So this is going to get passed in a name, which is a string, and another string, which is called a GPA. And then we're going to say this dot name is equal to a name, and this dot GPA is equal to a GPA. Okay, once again, if this isn't fully clear, that's okay. Don't worry about it. It's fine. So let's create a couple of variables. So we want to create a student variable down here, right? It's going to store a student object. So we're going to say student, and then why don't we call, this one's going to be Jim, and Jim is going to be, so we're going to call the constructor function. So his name is Jim, and he has a GPA of 2.5. And then we're going to create another student called Pam, and Pam is going to have a, let's do 3.7. Pam's pretty smart. Okay, so we have Jim and Pam, and they're both students. And then down here, this is just like we did before. So we can print out, Jim.GPA, whatever, and that should work. And actually, whoa, so I messed this up. I said the GPA was a string. This should be an integer. Or no, this should be a double. And then down here, yeah, I'm sorry, I messed this up. Okay, so down here, these are both doubles. So this data type just needs to be a double. Common mistake. Okay, so now let's see if we can get Jim's GPA to print out. Cool. So the last big concept here is that inside of these classes, we can define functions. And technically, when a function is inside of a class, we would call it a method. So this is I've been saying the word function and method interchangeably. Technically, if you want to get like really technical with this, if you're on Stack Overflow, you want to make sure that that you're technical or people are going to yell at you. But a method is a function that's inside of a class. I think that's like the official definition. Anyway, so what I'm going to do in here is I'm going to create a function inside of this class that both of my students are going to be able to use. So you can just create this function like anything else, and what this is going to do is it's going to return a Boolean value, and we're going to call this has honors. Has honors. So what this is going to do is it's going to tell us, based on their GPA, whether or not the student has honors. And so we're going to say that like honors would be like, they're distinguished in their class or whatever. So if a student has honors, it means that their GPA needs to be 3.5 or above. Let's just say that's the criteria that we're working with. So what I could do then is I could return whether or not the GPA, this .GPA, is greater than or equal to 3.5. I'm going to explain what this does in a second, but let me just show you how this works. And so now, because I've defined this function inside of my class, I can call it. So I can say Jim.hasHonors, and this should print out true or false. So you can see that Jim doesn't have honors because his GPA is not greater than or equal to 3.5. If we did this with Pam, though, Pam run, Pam does have honors because her GPA is 3.7. So this whole concept, it's this idea that we can create these little helper methods that are inside of our class, and any of the objects can use them. So the Jim object and the Pam object can both check to see if they have honors. And when Jim calls has honors, so when the Jim object executes this function, this .GPA is going to be Jim's GPA. When the Pam object executes this function, right, when Pam calls has honors, this .GPA is going to be Pam's GPA. So this function is particularly useful because it can be used on all of the objects that we create from this class. And one of the great things about this is that if we wanted to change what the qualifications for honors is, so maybe instead of 3.5, we move it down to like 2.0. Well, now I change this in one place, and when I rerun my code, now we can see that both of them are having honors. So I can change what the qualifications are for honors just by changing the value inside of this function. And that is really, really powerful. Okay, so we've talked about and we've introduced some of the really core concepts in object-oriented programming. And now the last thing that I want to do is really, and this is going to be the last thing that we're going to do for this course, is I just want to bring everything together. So we've looked at, like I said, all the core concepts of computer programming. I've walked you through each one step by step. Now we're going to take all of these and we're going to build our final program, our final project, and it's going to use all of these different things together. So what we want to build is we want to build a little quiz program. And what this program will do is it'll essentially walk the user through taking a quiz, and we'll be able to grade that quiz as the user goes. So we'll ask the user some different questions, they'll answer those questions, we'll keep track of how they're doing, and then at the end, we'll sort of give them their grade. And I want to do this with math questions just because I think it's kind of an easy way to do this. So we're going to write a program that can give people math tests. So it'll ask them math equations, and then they can answer them. So I'm going to walk you through this, and we'll use object-oriented programming in this as well. So let's go ahead and get rid of our little student class here. And what I want to do is I want to create a class which is going to allow us to model math questions, because the program that we're going to build is a quiz program. And one of the most important parts of any quiz, right, is the questions. And a question is a good example of something that we could put into its own class or into its own object because it has multiple properties. So there's two properties to our math question, and I'm going to create a class for this. So I'm going to say class math question. And this, like I said, it'll model a math question, and there's going to be two properties, two attributes that are part of this class. So the first is going to be the actual question itself, and this can be a string. So the question could just be, stored in a string. It could be something like 3 plus 5, or, it could be 20 times 10 divided by 3, whatever, just some math equation that we want to ask the user to try and solve, see if they can solve it. That's going to be this question. The second part of any question is the answer. So we need to know what's the actual answer. And once again, why don't we have this be a number? So I'm going to have this be a double, and this is just going to be answer. So the question is in the form of a string. Like I said, it could be 3 plus 3. The answer is going to be in the form of a number like 6, for example. And you could make this a string as well. It's not super important, but I think it's better that it's a double. So we have our question, and this will allow us to model a question in our program. Now, what I might want to do down here is I want to actually create some of these questions. So we'll go ahead and create all the questions that we want to have in our quiz. Now remember, the way that we can create a math question object is by first specifying the data type. So we're actually going to store this in a variable. So we want to specify that this is going to be a math question, and we're going to store it in a variable called question1. And I'm going to set this equal to, and remember, the way we create this object is just by saying math question like that, and then this will call the constructor, which we've just talked about a lot. So what we want to do is create the constructor. So let's go ahead and do that. We can say math question, open and close parentheses, and then an open and closed curly bracket. Now, inside of the parentheses, we want to specify that we need to initialize the question and the answer. So we're going to take in a question, and then we're also going to take in a double called a answer. So when I create the math question down here, I now need to pass in the question. Why don't we just do 3 plus 5? And then I need to also pass in the answer. In this case, it's going to be 8.0, right? Because this needs to be a double. So in the constructor, I want to initialize the question and the answer. So I can say this dot question is equal to a question. And remember, this line of code here where I'm just saying this dot question, It's the same as if I said question1 dot question is equal to whatever. We'll do the same down here. So I could say this dot answer is equal to a answer. And it's the same as me saying question1 dot answer is equal to whatever the answer is. So we're calling the constructor to create the object. I'm passing in the question, I'm passing in the answer. Both of these arguments are getting stored inside of these parameters up here. And then I'm initializing the object with those values. So this is all that same stuff that we've been talking about. Okay, so I can create one question. Why don't we also make another question? So we'll make 2. So this will be question 2. And why don't we change this one up? So this one can be like 10 minus 7. And in this case, we're going to get 3.0. Now you can create as many of these questions as you want. I'm just going to show you like kind of how this works. But theoretically, you could have thousands of questions if you wanted. Now here's a situation where you can see that we're creating like question 1, question 2, and actually let's make one more because I think 3 is really going to drive the point home. So we have question 1, question 2, and question 3. This one is maybe 100 times, I don't know, 11. Or no, let's do 100 times 9 so we can get 900. Okay, so we have 3 of these questions. Now, one thing I want you to notice about these questions is that we're using these like numbered indexes, right? So I'm like, okay, this is question 1, this is question 2, this is question 3. And it makes sense that we need 3 questions because we're making a quiz. The quiz probably should have more than one question. Now, when you have a situation like this, where we have multiple different questions, right? In this case, all of these questions are just question 1, question 2, question 3. This is a great place to use a list. So we've talked about these lists. A list is a data structure that we can store different values in, and it's just one related collection. So because I have multiple questions, because I have multiple pieces of related data, I want to put these in the same data structure inside of the same list. So instead of creating 3 separate variables down here, which are storing 3 different math question objects, up here, let's just create a list, and this is going to be a list which is going to store math questions. And you don't want to make this plural, you just want to say like math questions. So this is a list of math questions, and we're going to call this questions, and I'm going to set this equal to an array or a list. And so inside of this list, instead of creating 3 variables, we're just going to put these objects. So I'm going to copy this object, I'm going to put it in here, right? I'm going to put a comma, and I'm just doing this on different lines just so it's cleaner. I'm going to copy this one, comma, and then finally we will do this as well. So instead of creating 3 objects and then storing these objects inside of variables, instead we're just going to put all of these objects inside of this list. Now, one thing I want to point out, because I think this can be confusing for beginners as well, is really what we're doing on this line here is we're storing this object. So this right here, what I have highlighted, this is the object. And I'm storing that inside of a variable called question1. So that's what we're doing here. I'm specifying I want to create a variable that stores a math question. That's this. It's going to be called question1. And inside of question1, I'm going to store this math question object. So this over here on the right side, this is the object. This over here is all the stuff for the variable. Now in this case, I'm not storing this question inside of this single math question variable. I'm storing these objects inside of this questions list. Cool, so now we have this questions list, and this is just like any of the other variables that we've looked at. So I could print out like questions at index position 0, and you can see that that gets printed out over here. Now, we would want to say, instead of just printing out questions at index position 0, I could say questions at index position 0 dot, and we could, I could print out the answer or something. And this is really common. This is something that we haven't seen yet, but really what I'm doing is I have my questions list here, okay? I'm accessing the 0th question, so this would be this first one, right? So I'm accessing the 0th question. So now this whole thing, like what I have highlighted, this whole thing might as well just be that. this whole thing might as well just be this object. That's essentially what it is. So we're referencing this first object here, and now I want to get the answer out of that. So if I wanted to get the answer to this third question, or I could do questions 2, and that would give me that. So this is really common, is we have these complex data types, these math questions. This is a custom data type that I created up here. So I created this, and now I'm storing 3 of these inside of this list. So now I have, for my quiz, I have this list of 3 questions that I might want to use, and I can access specific ones of these, for example, by saying like questions 1.question, and then that'll give me that. Okay, so this is really, really common, is that we're doing something like that. But this isn't all everything for the quiz, right? This is the first part. And generally when we're building applications like this, you're going to have the data and then you're going to have the logic. The data is this stuff. So this is the data that our program is going to consume and our program is going to use. In this case, it's just math questions. In other applications, it might be other different things. But we have our data now, which is set up. So this is all the data. Now what we want to do is we want to actually turn this into a little bit of a game. So I want to go through each one of these questions. I want to ask the user each one of the questions. I want to get the user's answer, and then I want to keep track of their score. So we're going to do this step by step. The first thing that I have to do is I have to use a loop. And the reason I need a loop is because I want to be able to do the same thing for each one of these questions. I want to be able to run the same code for each question. Basically, for each one of these math questions, I want to ask the user the question and I want to get their answer. Okay, so let's go ahead and do that. The first thing we'll do is we'll actually just loop through this array, and let's just start with that. So why don't we just loop through the array and print out all the questions. So we'll loop through the list and print the questions. So we're going to use another one of these for loops. Now we're going to use this for in loop. We talked about this. Whenever you have an array data structure or list data structure and you want to loop through each element and do something, the for in loop is your best bet. So we can say for, and this is going to be math question. So this is the data type. I'm going to say math question, and why don't we just say this is called question in questions. So I'm creating this little question variable here for each one of the questions, and then down here I could print out, for example, question dot question. Okay, why don't we call this math question, just so it's not confusing. So we can say math question dot question. And when I run this, you'll see that for each one of these, it should print it out. Now I spelled this wrong, so that's not going to be good. But you can see for each one of these math question objects, we've printed out the actual question itself. Now, the fact that this is called question, maybe this is getting confusing. You could call this like question text if you wanted. I'm just going to leave it like that for now because I think it's fine. But if you're getting confused, you can rename these variables. Okay, so this is the first step. We have our data, and now what I want to do is I want to loop through the data. So for each one of these math questions in the questions array, I want to print out the question, right? There's 2 components to each one of these. There's the question, which is a string, and then there's the answer, which is a double. So this is good. This is our first step, but remember, we don't just want to show the user the question. I mean, we want to do this, right? We want to show them the question, but we also want to get their answer. And this is going to go back to all that getting user input stuff that we did earlier. We have this prompt double function. Remember that we wrote this before. So the prompt double function will print out enter a number, and then it will say, double my num, and we like kind of parse this out. I went through all of this in a previous section. So if you don't remember what we were doing here, you can go back and watch that. But basically this will allow us to prompt the user for a number. And this is something that we will actually want to use in our little program here. Now, one thing I want to change about the prompt double function is I don't want it to say enter a number. Instead, I want it to say the question over here. So I'd want it to say like 100 times 9 or 10 minus 7. Or 3 plus 5. That's what I would want to say. And we have a way of doing that over here in the prompt function. So remember, the prompt function takes a string, which is prompt text, and then we print that down here. We're going to do the same thing. So I'll just copy this. And here in the prompt double, this is going to take as a parameter the prompt text, and then we're just going to print that out here. So I'll say prompt text. So this prompt double function now, what it does is you can pass it in a prompt text, and we're going to end up passing it in like 3 plus 5 or 10 minus 7 or 100 times 9. It'll print that out, and then it'll allow the user to enter a number, and then it'll return that number to us. So this is a really, really useful function now that we can use. And I'm going to go ahead and use that down here. So every time that we go through this loop, so for each one of the math questions inside of this questions array, I want to ask the user the question, and then I want to record their answer. Basically, I want to get their answer back. So let's go ahead and do that, and we can use the prompt double function. The prompt double function now, it takes a prompt text. So it takes a string called prompt text, and then that's what it's going to use to prompt the user with. So down here in prompt double, we're actually going to pass in math question.question. So we'll pass this into here, and let's see what happens now. So theoretically, like if I did this correctly, which I think I did, what should happen now is it'll go through, it'll prompt the user with the question, and then it'll allow the user to enter in their answer. So 3 plus 5 is 8. I could hit enter. So it prompted us for that double. Now we're not doing anything with that, so nothing really happens, but you can see how this is working. So 10 minus 7, that's 3, and then 100 times 9 would be 900. So I've sort of created this program now where it'll go through each one of these questions, and it'll use the question property as the prompt, and then it'll allow us to enter in the answer. So this code right here, it's very simple, but it's very powerful because now we can loop through each one of the questions and do something. But this alone isn't, this isn't really the game, right? This isn't the quiz that we want. We want to be able to get the user's answer and check to see if they got it correct or not. So I'm actually going to take this prompt double stuff. Now remember, prompt double is going to return the number. So this will actually give us the number back that the user entered. So I can store that inside of a variable. So this is going to be a double, and I'll call it answer, or why don't we call it user answer. Some of these names are going to start to get a little confusing. Hopefully you can stick with me. So double user answer. So we're going to store whatever the user answered for this particular question inside of here. Now this is going to happen each time we go through the loop. So it's going to happen for each one of these questions. Now what we want to do is we basically want to check to see whether or not they got the answer correct. And we can do this using an if statement. So what I'm going to do is I'm going to check to see if the user's answer is equal to the answer to the question. So I can say math question.answer. Now this is what we want to do, because remember, user answer, this is what the user enters in. So if I come over here and I enter this 8, that's going to get stored inside of user answer. And I want to check then to see if whatever the user entered is equal to whatever the answer was to the question. When I created all of these questions, I passed in the correct answer. So I had to say, hey, this is the answer to this question. So down here, I'm just checking to see if what the user entered was what the answer is supposed to be that we entered in up there. So if this is the case, we can print out correct, and then otherwise, we'll use this else, we can print out incorrect, and then we could also say like incorrect, the answer was, and then we can interpolate in here math question.answer. Okay, so one more time, let me just walk you through what we did here. So we got the user's answer using this prompt double function that we wrote earlier in the course. That's going to be stored then inside of user answer. So it's whatever the user put in over here on the console. If the user's answer is equal to the answer to the question, which we specified up here when we created these objects, then we're going to print out correct. Otherwise, we'll print out incorrect, and we'll tell them what the answer was. So let's go ahead and see if this code works. I'm going to run this. Okay, so it says 3 plus 5. So let's try to get one correct. So 3 plus 5 is 8. So I'm going to hit 8. Now what should happen is I'll hit return, I'll hit my enter key, that 8 will get stored inside of user answer, and then we'll check that against the answer to the question. The answer to the question is this 8, so it should print out correct. So I'm going to hit enter, and you'll see that it says correct. Cool. So now we have 10 minus 7. I'm going to get this one wrong. The answer to this should be 3, but I'm going to put a 6 in here. So when I hit enter, once again, we'll store that 6 inside of the user answer variable that's coming from this prompt double function. I'll check to see if the user's answer, which is 6, is equal to the answer to the question, which is 3. That's going to be false. So then we'll come down here and print out this incorrect. So I'm going to hit enter, and you'll see it says incorrect. The answer was 3. And then finally, 100 times 9, we can just put in 900, and that'll be correct again. So right here, this is combining all this stuff that we've learned. We have lists, we have object orientation with these math questions, we have for loops, we're getting user input, we're using if statements. All of these different things are being used here. And really this like brings all of this stuff together in I think kind of a nice way. Now this is fine, so this is a good way of doing it, but instead of saying like correct or incorrect or correct here, I want to show you how we could actually like keep track of what the user does and then give them a grade at the end. So instead of just telling them right away, we could say like, hey, you got 2 out of 3 correct. So you got like 66% or whatever. What we want to do in order to do that is we can create an integer which is called score. And this is just initially going to be equal to 0. So every time the user gets a question correct, instead of printing out correct or incorrect, instead we're just going to increment this score. So when the user gets a question correct, we'll add 1 to their score. If they get the question wrong, then their score will just stay the same, so they won't get an extra point. And in order to do this, it's actually going to be really easy. So you can really get rid of this else. And then inside of this if, instead of printing out correct, you can just say score plus plus. So now each time we go through this for loop, if the user gets the answer correct, we'll increment the score. And that's all we're going to do in here. So let me clean this up a little bit. Now down here, outside of the for loop, I can print out using this information. So I can say, and we'll use interpolation here, you got, and I want to say how many they got correct. So this is going to be their score. And then we'll say like out of, and then we want to put how many questions there were total. So we can figure out how many questions there were total by saying questions.length. So here I'm saying you got, and then this is the number that they got correct. Remember, score is incremented every time the user gets the answer correct. And then we say you got score out of questions.length. This is just going to be how many questions were inside of this array. And we've looked at that before in the array section. So let's go ahead and run, and we'll see how we did. So I'm going to get this one correct. We'll get 10 minus 7 correct, and then we'll get the last one wrong. So now it should say you got 2 out of 3, just like that. Awesome. And then if you wanted to give them a percent, like we could just divide these. So you could take the score and divide it by the number of questions. And actually, we might need to multiply that by 100 too. So 8, 3, whatever. Okay, so yeah, and if we multiply that by 100, then we should get a score. Okay, so why don't we try to get 100%? So I'll get 8, 3, and then this is 900. It says you got 100, and then we can run it again, and we'll just get one of them wrong. So 8, 3, 8, and now we got a 66. Perfect. So that is the final project in this course. This is our little questions thing. And let me say this. So all this code will be available, but let me say this, like, if you can understand this question game, you are like solid. You are a solid computer programmer. Seriously, this program right here is the culmination of the last, whatever it is, 4 hours that I've spent teaching you Dart. So if you can go through this and you feel like you understand what it's doing and you feel like everything's working, like you have learned all of these core concepts at least a basic level. So this is like a good benchmark to measure yourself against. If you can go through and write this entire program without referencing this video, then I'd say you're on like a pretty good track, okay? And look, if this is confusing to you, like absolutely no worries. This is a pretty complex program. So I put this in here intentionally because it is pretty difficult and because it combines all of those topics, okay? But it's something to, I guess, strive towards. But really, like I said, it combines everything that we've done so far, and yeah, I'm pretty happy with this. All right. This is a long tutorial. It's like 4 hours. But we've covered everything that I wanted to cover, so I'm really happy about this. Now, let's talk about next steps. So this Dart programming language, really useful. I love this programming language. I've had a blast filming this video. And really what you want to do with Dart, and really kind of the whole reason why Dart exists, is there's this other really cool framework which is called Flutter. And Flutter can be used to build mobile apps. It can be used to build web apps. I think probably soon it'll be able to build desktop apps. This is something that's been developed by Google kind of from the ground up, and it's a really solid framework. I don't have a Flutter tutorial at the time of making this video. I'm making the Dart tutorial first as kind of an introduction into that. So I do plan on making a Flutter tutorial. If you want to see a Flutter tutorial, you want to learn how to build some apps using this stuff and take it to the next level, just leave a comment or a like on this video. Let me know that you want that, and maybe I can get around to it in the next couple weeks. But otherwise, I'm pretty happy with this. So I just want to say thank you so much for watching. If you've enjoyed the course and you want to support me and help me to keep doing this, you can leave a donation. The link is in the description. I always appreciate that. But otherwise, yeah, this has been great. Thank you for watching, and I will see you in the next one.